It's your favorite NPC, and today I'll teach you Python. We go over what Python is, how to install it, variables and data types, functions, loops, if statements, classes, API calls, and a lot more. I'll show you everything you need to know about Python. Whether you want to use Python for creating artificial intelligence, web development, scripting, or something else. After this course, you will have all the necessary tools. So let's get started, guys. Python is a high-level, general-purpose programming language. It was created in the early 1990s by Guido von Rossum. The goal was to design a language that is simple to read, efficient to work with, and powerful enough for real-world applications. Programming languages are often categorized by how close they are to the hardware. Low-level languages operate very close to the hardware and give direct control over memory and system resources, which usually results in higher performance. Code written in low-level languages is therefore often faster, but also significantly more complex. Mid-level languages sit somewhere in between, offering abstraction while still allowing limited low-level control. High-level languages like Python are far removed from the hardware. The interpreter handles memory management and system interaction, which simplifies development but reduces raw execution speed. Even though this reduction in speed sounds like a big drawback, it usually isn't for most use cases. This becomes obvious when you look at the most popular programming language today, Python. The purpose of Python is productivity and problem solving. It is designed to let developers focus on what they want to build instead of how the hardware executes each instruction. Because of this, Python is not used for low-level system programming, but for logic-heavy applications, data processing, and system integration. In practice, Python is used across many domains. It is widely used for back-end web development, automation and scripting, data analysis, scientific computing, and especially artificial intelligence and machine learning. In the AI ecosystem, Python has become the standard, with most major frameworks and research tools built around it. So whether you want to work in AI, web applications, data science, or automation, Python often sits at the core of the stack. So should you learn Python? And you definitely should, because it offers a strong balance between power and accessibility. A single language opens you the door to multiple fields and remains useful as projects and requirements scale. To get started writing Python code, we need Python to translate our written code into machine code, and we need a code editor to write Python code. So let's go to Google, let's just enter Python, download. Let's go to the first link right here. Let's go to downloads. And let's try to get the standalone installer for Python 3.14.2, so for the latest version. This will start your download for the standalone installer. Once downloaded, you can just press the installer. This should open this window, and if you're on Windows, you want to add the python.exe to your path, so press that. Let's click on install now. This includes IDLE, pip, and documentation, and especially pip is later on very important. So let's press this and wait for the installation to finish. And now the setup was successful. So now we can just close this. Let's go back to Google and let's search for PyCharm, because that is going to be the code editor that we'll use. Click the first link. This page will open and now you can just press download. And let's just press download again. This will now start to download the .exe file. Once done, let's press the .exe file. Let's press next. This here's fine. Next. Let's press add bin folder to the path. Let's also create the association.py, and if you like, you can add PyCharm as a desktop shortcut, but that's up to you. Let's press install and wait for the installation to finish. And once complete, we can just press finish. Now we can open PyCharm by just searching for it and pressing it. We have to accept the terms of the user agreement, continue, and this should open PyCharm like this. Let's now create our first project. So just press the new button right here, new project. You can see right here we can define a location. So let's create a location, or let's create a project or a folder for our project on our desktop. I right click, new folder, test for example. And I'm going to select that as a folder. Like so. So we create the project within this folder. This here is fine. Also select project, venv, and right here the Python version. And this should be fine by default for most of you. Now let's just press create. And this will create a new project. It will also create this venv folder and this main.py file for you. And within this main.py file, we can now write Python code. Let's start by understanding the print statement. The print statement can be used to output something in the console. You can use it by using the print keyword, followed by opening and closing brackets, and within those brackets you just define what you want to output in the console. So this could be a little bit of text, for example. And text always needs to be within quotation marks, like so. And now the text could be Python is easy, for example. We can now execute the code by pressing this play button, so run main.py, and this will open the console. And right here you can now see the output, so Python is easy. We're not limited to text though, we can also just output a number, so maybe 100. Let's press play again, and this will now output the number 100 in the console. And we can also output multiple things by just using 100, for example, and then maybe 200, like so. And now we get 100 and 200. And of course, the second argument can also be text. So this is simple text. And if we're going to run that, you see we're getting 100 and this is simple text. Let's now understand variables and data types. A variable is just a placeholder. So imagine you have a little bit of text. So Python is easy, for example. Now we're just having this text right here, but we're not really using this text in any way, and we're not really storing this text in any way. So this is something that we should not do in Python. So we should either do something with the text, so print the text, for example, or we should store the text somewhere. And in order to store it, we can create a variable. The text variable would be an example. The text variable could be equal to Python is easy. And you define a variable in Python by just using a variable name. And this here can be literally anything, but I prefer to use descriptive names. So text might make a little more sense. Now we can also define a name, for example. So our name could be NPC, or we could define our age. So age could be 101. So I'm pretty old already. And a variable is pretty similar to a package, for example. You put something into the package, and later on, when you need it, you can essentially open the package and get what is inside. And a variable is the exact same. You store something inside the variable, and later on, you can start to use it. So now I could, for example, use the print statement, and I could access text. Let me run the program, and we are getting Python is easy right here. We can also output our age, like so, and we're getting the age in the console. Let me now introduce you to data types in Python. Previously, we've defined a variable of name, for example, and that variable was equal to a name, for example, so to a little bit of text like Jonas. And by defining this variable right here, so the variable Jonas, within quotation marks, we implicitly in Python define the data type. So text in Python has the data type string. So this right here is a string. How does Python know that this is the data type string? You define it by using those quotation marks right here. So whenever something is inside of quotation marks, Python knows that this is going to be a string, so a text. And you can also use single quotation marks, and this would have the exact same effect. So this is valid as well. If you want to store a whole number, like age for example, you can just set it equal to a whole number, and Python will know that this is going to be an integer. So a whole number is what you call integer in Python. So 100 years, for example. But of course, in the real world, there also exist decimal numbers, like money, for example. So maybe on your bank account, you have $0.99. And that's actually pretty accurate for me, guys. Nevertheless, by just using a decimal number, you tell Python that this is going to be a float, so a floating point number. If something can be either true or false, you can use a boolean. You could, for example, define the variable is _broke, and I'm obviously broke, so this could be equal to true. In this scenario, a probably unrealistic alternative would be false. So by using true or false, you tell Python that this is going to be a boolean, and the boolean can either be true or false. So it's pretty similar to a light switch, which can be on or off. And if you do not have a value yet, or do not know the value yet, you can also use none. So maybe you're calculating a result, but you do not have the value yet, and then you can just set it to none. So this means we just do not have a value yet. Let's now understand f-strings in Python. Imagine you have a variable name, for example, that is going to be equal to NPC. And now you want to print out this variable, and maybe you want to say hello NPC, for example. But we want to use the variable within the string. In order to include this variable within the string, we can use an f-string, and once we use an f before a string, we can use those brackets within the string, and within those brackets we can now access our variables, for example, so name. Now we can run this code and you can see we're getting hello NPC. We could also add an age right here of 101, and now we could also add the age. So you are age years old. Let me run this code and we're getting hello NPC, you're 101 years old. So by using an F string, you could use variables, for example, within a string. Let's now understand how to get input from users in Python. To ask a user to enter something within the console, we can use the input method right here, followed by opening and closing brackets. And right here we can now define a prompt. So enter your biceps size, for example. Let's now run this command. And you can see we're getting enter your biceps size. And now I can enter a size, I can press enter, and the process finished with exit code 0. If you take a look at the program, once I remove this input field, you can see that the process immediately finishes. When we use an input field, the program will wait for our input though, and only after we've submitted the input, the process will finish. So this here always waits for the user to enter something, and then the process finishes. We can also store the user input in a variable. So this could be the variable biceps underline size, and that one is going to be equal to whatever the user enters. And now let me just print our variable biceps underline size. And I'm going to run the program again. I'm first going to enter my size, so 24. And now we will print 24 in the console. And let's make this a little bit nicer. So colon, space, print, and let's use an F string again. So F, your biceps size is, and let's insert our biceps size right here. Let me run the program. Bicep size, maybe 24. Your bicep size is 24. So this is how you get user input in Python. Let's understand strings a little bit better and how to manipulate them. A string like first underline name will be defined by using quotation marks. So starting and ending quotation marks. And right here we can now just use a little bit of text. So the first name could be Skinny, for example. Now we can also create a last name, and that one could be Man. So my first name is Skinny and my last name is Man. And now I can concatenate two strings by using a plus. So let's print this out. So first name plus last name. Let's run the program. And you can see we're getting Skinny name. We could also add a space right here and concatenate that string with our last name. And now we're getting Skinny Man. So by using a plus, you can concatenate two or more strings. We can also output the length of a string by using the len method. And within the method, we just pass our first name, for example, so a string. Let's run this, and we're getting 6 because the length of the string is 6. So 1, 2, 3, 4, 5, and 6. We can also access a certain character of a string by using the string name or the variable name, followed by those brackets. And now we have to use the index of the character we want to access. So index 0, for example. And right now we're getting the S. So Python starts counting from 0. So this here has the number 0, 1, 2, 3, 4, 5. This here would be 0, 1, 2. If we want to get the last character, we can use -1. So this starts counting from the end. Let me show you. We will get a Y. -2 would be N, for example. We could also define a start and an end. So start, end would be the formula. Let's start from index 0. So 0, 1, 2. And let's go to index number 2. But this will exclude index number 2. So we will get 0, 1, and 2 is right here. But we will not get 2 because this is excluding number 2. If we want to get everything to the end, we can use -1 as well. And now, of course, this excludes the last index as well, so the Y. So let's get everything from 0 to 5. And we can also define the steps. So let's define 2 steps, for example. And this will only give me every second character. So S, I, N. We can also go from 0 to the end by just using 0, and this will say just go from 0 to the end and use 1 step. Let me play this, and we're getting the entire string. We could also use colon, colon, followed by the steps. So let's use 2 steps, for example. And this will get me every second character. So S, I, N again. You can also use for, just to show it to you. And we're getting S and N. We could also say, get me everything from the beginning to character number 4, for example. And now we're getting SKIN. So everything from 0, 1, 2, 3, and 4, but excluding 4. We can also turn all of the letters to lowercase by using first underline name dot lower, for example. So we call the lower method on this first name. And we're getting skinny and everything is lowercase. We can also use dot upper. And now everything is uppercase. And we can also use capitalize to capitalize the first letter. But this shouldn't change anything because the first letter is already capital. So let me replace that one with a small s. And now we will see it's still capital. Now imagine we'd have a lot of space bars right here. Let me play this. And now you can see we're having all of those spaces right here. If I'm going to use dot strip, for example, it's going to remove all of those white spaces at the end and at the beginning. So you can see we removed all of the white spaces, and I can also add a couple of white spaces here, and this still removes all of the white spaces. Without the strip method again, we would have all of those white spaces. So let me remove all of them, and we can also remove a certain word. So we could, for example, use first name dot replace. Right here I first have to define the old word, which is going to be skinny, and the word I want to replace the old word with. And in my case, this should be huge, for example. Let me play this. And now we're getting huge. And if this here would be skinny NPC, and I'll play this once again, we're getting huge NPC, which is probably a little more accurate. So let me remove this one. And we can also find the index of a certain character, for example. And this might be pretty useful from time to time. So you can use the find method. And now imagine we wanted to find the position of the character n. So the first occurrence of this character. And we're getting 3. So 0, 1, 2, and 3. If I'm going to use y, for example, we get 5, and so on. So find will always return the index. Alternatively, you could also use the in operator. So we could check if y is in first underline name, for example. And right here we are getting true, because the letter y is in the word first name. We could also check for o, which of course is not in the word skinny, and we're getting false. If I'm going to search for skinny, for example, we are getting true because skinny of course is in skinny. So this is, for example, useful if you have an email, and then you could say, is the @ symbol in first name, for example. Of course, this would not be the best form of validation, but this would be a simple option, I guess. We can also check whether our string, first name, for example, starts with a certain character. So maybe SK, we're getting true. SKS, we're getting false. So this checks whether our string starts with a certain character sequence or not. Of course, we can also use ends with, and we can say com, for example. That's of course going to be true, and that of course is going to be false. Let me just replace this with skinny again. Now it's also possible to split a string into certain parts. So we could, for example, use split for that. And we can say that we want to split our first name whenever we have a comma, for example. And now I'm just going to add a comma right here and one right here. So this method will split this into 3 parts, that part, and that part. And you can see we're now getting 3 different parts. And this here is a list. You do not have to understand this yet, but we'll get there later on. Something that you might do a little more often is just use a space to split them, because now you can split different words. So skinny guy is broke, for example. And you can see we're getting skinny, guy, is, and broke. Now we can also count the occurrence of a letter, for example. So we can say how often do we have the letter N. And we're getting 2 because we have the letter N twice. If I'm going to add 2 more N's right here, we would have 4. We can also check whether this is digit, for example. So whether this only includes numbers. We're getting false because of course this is normal text. But if I use 1, 2, 4, we're getting true because now those are all digits. And the opposite would be to use is alpha, for example, and this now just checks whether everything is basically a character. And we're getting false because those are numbers. But if I'm going to use skinny again, we're getting true. Now there also exist a couple of escape characters. So let's imagine we're just outputting, hey guys, for example. But now I maybe want to use quotation marks in here. But since quotation marks have a special meaning within Python, this is not really valid. So you can see this does not really work. To use quotation marks, I can use an escape character. And the escape character in Python is the backslash. And now I can use the quotation mark right here. And I can use another backslash right here, for example, like so, and a quotation mark. And this will say, this here is not going to be Python code, this is just going to be a normal quotation mark. Let me run this, and we're getting hey guys within quotation marks. We can also use a slash or a backslash n to create a new line, for example. So this tells Python this is not going to be a normal n, this is going to be a new line character. So this will generate a new line. And we can also create a tab, for example. So those were the most important ones. If you ever need any other escape characters, you can always look them up. But I personally never use any other characters, and I barely even use them. But it's good to know that that exists. Also, I want to show you one more thing. Imagine we're having the number 10 as a string, and now we'll add the number 10 as a number. Let me show you what is going to happen. You can see we're getting an error. So this does not work. But what if we add 10 to the string 10 right now? And you can see we're getting 1010. So this here is not a mathematical operation. This only adds or concatenates two text inputs. So this here will not be interpreted as number, but rather as text. And therefore, it's just going to concatenate those numbers as text, because essentially we'll define it as text. So it also makes sense. Let's understand how to work with numbers in Python. Let's create a num1 that could be equal to 5 and a num2 that could be equal to 10. In Python, you can use all of the basic math operations. So you can print, for example, num1 plus num2. So addition is completely fine, and we will get 15. You can also subtract those numbers, so num1 minus num2, for example, and we will get minus 5. Multiplication works as well by using the asterisk, and we would get 50. And we can also divide num1 by num2, and we will get 0.5. We can also raise num1 to the power of num2 by using two asterisks, like so. And let's actually make a simpler calculation for that one. So let's raise 2 to the power of 4, for example. So 2 times 2 times 2 times 2. And this should give us 16. And you can see we're getting 16 in the console. There also exists the modulo operator. And that one might be a little bit confusing for a couple of you, but you'll understand this in a second. And let me actually do 4 and 2 right here. And we will get 0 in the console. Why do we get 0? Because 4 divided by 2 is 2 rest 0. So the modulo operator always outputs the rest. If we would divide 5 by 2, for example, we would get 2 rest 1. So the rest is going to be 1, and we will see 1 in the console. If we would now have 3, for example, and 8 right here, then we would have 2 rest 2. So we will get a rest of 2 in the console. So that is pretty much all this right here does. We can also add something to number 1. So we could, for example, say that number 1 is going to be equal to number 1. So num1 plus 10. And now let's just print num1 in the console. Let's press start. And we're getting 18. So I can increment a number by doing so. But there's also a shorthand syntax for the exact same thing. So we can say num1 plus equals 10. And this says num1 is equal to num1 plus 10. And we're getting the exact same result. You can also do minus equals. So now this means num1, so 8, minus 10 will be assigned to num1. So we get minus 2. And you can see we're having minus 2. And of course, multiplication works as well. So we're getting 80. Division works as well, 0.8, and even the modulo operator should work. So we're getting 8, because the rest is of course 8. If we would have 10 right here, then we would have 0, because then the division would work perfectly fine, so the rest would be 0. Let me also print the result of a division for you. So let's divide num1 by num2, so 4 divided by 2, and let me remove this line right here. And let's just print num1 divided by num2 like so. And we're going to play this, and you can see we're getting 2.0 in the console. So even though we're using two integers, so two whole numbers, we're getting a floating point number, so a decimal number in the console. And the reason for this is, when using division, Python will always return a floating point number, no matter what. And of course this makes sense if you think about division, because 5 divided by 2, for example, would be 2.5. So without floating point numbers, it wouldn't really be possible to display a large variety of divisions. And also, I think that is pretty much obvious, but normal math operations work the same way in Python. So if we would say num1 times num2 plus 10, for example, multiplication would come before the plus, like so. And of course, if you would use brackets then, the brackets will come before the multiplication. So this works the exact same way. So this is just normal math. Let's take a look at the most important math functions that you might want to use when working with numbers. In order to access a lot of the math functions, it might make sense to import the math module, like so. So I just use import followed by the module name. The module name is math in Python, so we have to import math. You know that we're accessing the module math if we are using math dot followed by one of those methods. So whenever you have math dot, you know that you're accessing the module. If you're not having math dot, you know that we're not accessing the module. And a module is essentially just a package that provides a couple of useful methods, for example. So for example, methods for building a sum and so on. So let's now use the print statement and let's print the number 4.6. I'm going to run the program and we're getting 4.6 in the console. We can now use the round function, so round, opening and closing brackets, followed by the actual value, so 4.6. And now we're getting 5. So this will round up if it's bigger than 4.5, and this will round down if it's less than 4.5. And as you can see, we're just calling the round function. So this here is a built-in function, as you can see. And you know that this is not a math function again, because we're not accessing math.round, but instead we're just accessing round. So round is built in. Let's take a look at a math function though. So we can access math.floor, for example, and this will always round down. So 4.4 will be 4, but 4.8 will also be 4. And we can also use math.ceil, and this will always round up. So 4.8 is 5, but 4.1 is also going to be 5. And now you know that this here comes from the math package because we're using math.ceil. We can get the absolute value of a number, so abs, followed by those brackets. Again, this is a built-in function. And let's get the absolute value of -5. And the absolute value is 5. And the absolute value of 5 is of course also 5. So abs will only return the value no matter the sign. So whether we have a minus or a plus here does not matter. The sign will be removed and it's only going to return the value. We can also use the built-in min function. We can pass a couple of arguments. So we could, for example, try to get the min of 4 and 10. And of course, the minimum is 4. So it will output 4, 4, 10, 2, for example. This will output 2, and so on. We can also get the max by using the max function. And this will output 10. So the maximum is 10, of course. And we can actually also build the sum. But if we want to build the sum, we need to pass this as a list. And you do not need to understand lists yet, but just remember that this here is what a list looks like. So if I'm now going to press play, it will create the sum of 4, 10, and 2. And that of course is 16. We can also get the square root by accessing math.sqrt for square root. And let's get the square root of 16. And you can see the square root of 16 is 4.0. And again, we're getting this as a decimal number. Because of course, the square root of 16.5, for example, would be a decimal number. So it might make sense that Python converts this automatically to a floating point number. And some of you, maybe math or physics students, might work with pi. So math.pi might be important for you. And this right here will just output pi. So 3.145, whatever. Let me explain typecasting to you. Previously, we've already seen the example where we tried to add the string 10, so the text 10, to the number 10. And if you remember, this here throws an error. So type error. Can only concatenate string to string. But by using typecasting, we can now convert this string to a number. And we can do so by just using the type, so int, and in brackets we define our string. So we want to cast the string to the number 10. And now you can see that this here works, because now this here is an integer. We can also transform this to a float, so to a decimal number. And now we're getting 20.0. And of course this here could be 10.5 now, for example. And we're getting 20.5. Of course you could also remove this and now turn this number into a string, so str for string. And let's convert this number to a string. And now we're getting 10.510 because we're just concatenating those two strings. Something that might be interesting for a couple of you is the conversion to a boolean. We can do so by using bool. And now instead of those brackets, we can use a number, for example, so the number 1. And this will convert the number 1 to a boolean. And 1 in Python will also be interpreted as true, whereas 0 in Python will be interpreted as false. Now we can also do that with a string. So the string hello will be interpreted as true, for example, and an empty string will be interpreted as false. So you could, for example, check whether the user has entered a password, for example. So this here might be a password field, the user enters something, and if he does not enter something, you could tell him, for example. And you would know by just using this bool type conversion. Because this bool type conversion for an empty string, so for an empty password, for example, would return false. And those are the most important things you need to know about typecasting in Python. Let's understand if statements in Python. You use an if statement to check if a certain condition is true. And if the certain condition is true, you're going to do something. Otherwise, you could, for example, do something else. And this is pretty similar in the real world. For example, if someone wants to fight you and you know that you are stronger, you might just beat him, for example. I know a pretty good example. But if you're weaker, it might make more sense to run, right? And we can, of course, also do that in Python. So we could create a variable stronger, and this variable can be either true or false. So you can either be stronger or you can be weaker. If stronger is true, then you're obviously stronger. Now you can use an if statement by using if, so the if keyword in Python, followed by the condition. If stronger, for example. So if stronger is true, so if this condition is going to be true, then we are going to do whatever we define after this colon right here. And now we could, for example, just print, that's too easy. Now there's also the condition where I'm probably not stronger. So I can also define an else statement right here. So again, I need a colon after the else keyword in Python. And now I can define what I want to do if I'm not stronger. And under those circumstances, I want to print, I'm running as fast as possible, for example. And now I can just execute this code and we will get that's too easy because at the moment we're stronger. So that's obviously too easy. But if we are not stronger anymore, so if stronger is going to be false, then I'm running as fast as possible. Now we could also create a second variable and that one could be equally strong. So if he is as strong as me, then we could do something else. So we could, for example, first of all check if stronger is true. If that is the case, then we are just going to print that's too easy. But now there's also the possibility that we're equally strong. So I can create another statement, elif. So if stronger is not true, then we're going to check for another condition. And the second condition is going to be equally strong. And if we are equally strong, then we're just going to print that might hurt, for example. Because then the fight might go on a little longer and that might not be too nice. So that might hurt. But if we're not stronger and we're not equally strong, then obviously the other person is stronger. So I'm running as fast as possible. And now when I'm going to execute that, we're getting that might hurt because at the moment we're equally strong. So an if statement always has the same structure. You always start by using the if keyword followed by the condition. If this condition is going to be true, we're going to execute the code right here after the colon and stop right here. So we will never get to the other conditions right here. If this here is not true though, then we're immediately going to check for the second condition. In our case, if we are equally strong, if that is the case, then we just print this and we never get to the else statement. And if none of the conditions is true, we are always going to execute whatever we have after the else statement. and we can add as many elif statements as necessary. But you can only have one single if statement and one single else statement. And it's of course also fine to only use an if statement, so you don't need to have an else block. Let's understand a couple of operators, and you can use operators to, for example, expand the functionality of if statements. Imagine we are having a variable rain, for example, and at the moment it's raining, so rain is going to be equal to true, and we'll also have a variable cold, and it can either be cold or hot. So if cold is equal to true, it's cold, otherwise it's hot essentially. And now we can, for example, check if it's raining, so if rain is true, and we can use the AND statement to also check if cold is true. And now only if rain is true and cold is true, only then we are going to execute the code after this if statement. So when using AND, both of those conditions need to be true. And now we can, for example, print snow, because obviously when it's cold and it's raining, you will get snow. If I'm going to execute that, we will get snow. If I set cold to false, for example, you will see that we will not get any output because, of course, both of those conditions need to be true. I could also use the OR right here, and under those circumstances, even though it does not make too much sense in this case, only one of those conditions needs to be true for this here to execute. And you can see now we're getting snow, because rain is true and cold is false. If both of those conditions are false though, then we will not output anything. But if cold or rain are true, so one of those, then we will output snow. There also exist a couple of comparison operators. So we could, for example, check if Python is going to be equal to our text. If that is going to be the case, then we can just print all right again. Let me execute this. And we're getting all right because, of course, the text Python is equal to the text Python. If this is going to be false though, then we're not getting anything again. So this here checks for equality, and you can also use that with numbers. So let's create a number, 10 for example, and now we can check if number is going to be equal to 10. And always remember, one equal sign is the assignment operator. So this assigns the value to the right, to the variable to the left. And this right here, so two equal signs, is the comparison operator. So this only checks whether those values are equal and either returns true or false. And if our number is equal to 10, then we'll print all right. And at the moment, that's of course the case. Let me change that. And now we're not getting anything in the console because, of course, 11 is not equal to 10. We can also check whether this is not equal. So exclamation mark equal means not equal. And if this is not equal, then we're going to print all right. And we're getting all right because 11 is not equal to 10. We can also check whether 11 is greater than 10, and that is of course also the case. So we'll again get all right. If this would be 9 though, then we would not get anything in the console because 9 of course is not greater than 10. We can also use the less than symbol though. And now 9 is less than 10, so we should get all right. And we can also use less than or equal to. So let's test 10 for example. So for 10 we're getting all right because this is equal to 10. For 9 we will also get all right because this is less than 10. And for 11 we will not get anything because of course 11 is not less than or equal to 10. And of course we also have greater than or equal to. So this here is going to be true. This is going to be true. And 9 is less than 10, so this is not going to be true anymore. So those were all of the necessary comparison operators. Let's keep going by taking a look at the identity operators. And in order to show them properly to use, I want to use a list. You do not need to understand the list yet, but a list essentially just stores more values. So let's create a list X, and we create a list by using those brackets, and let's just have the values 1 and 2. And let's also create a second list, and that list will also have the values 1 and 2. And now let's just print x equals y. So is x equal to y? If that is the case, then we should get true in the console. And you can see we're getting true in the console because those lists look the exact same. If I'm now going to use x is y though, we will get false. And the reason for this being false is that when using the equal sign, so when using two equal signs, Python only compares the values. So is the list 1, 2 equal to the list 1, 2? And of course that is true. If we are using is though, then it's going to check whether this is the exact same object. And Python, of course, has to store this object somewhere. And since we're executing this code on our PC, those variables will get stored on our PC. And now is going to take a look at the memory address of X and the memory address of Y. And of course, there exist different memory addresses for X and Y because, of course, in fact, they are different objects. They just happen to have the exact same values, but that does not mean that are the exact same objects. And if Python now takes a look at the memory address on your computer of X is going to be different to the memory address on your computer of Y. And therefore, of course, you have two different objects in this case, so two different variables, and X is Y is going to be false. If you are going to check for X is X, of course, this is going to be the exact same object, even though this does not make too much sense right here. But we're getting true because, of course, X is X. And now you could, of course, also reverse that, so you can check if X is not Y. And now we will get true because, of course, X is not Y. And now let's also take a look at the membership operators. Imagine we're having a text, for example, and that text could be Python. And now we can use an if statement to check, for example, if py is going to be in the text Python, so in our text. If that is going to be the case, then we can just print ayo. Let me execute this program. And we're not getting anything in the console because, of course, py is not in the text Python because this here is not a capital letter. Let's turn this into a capital letter though. And now we will see ayo in the console because py is in the text Python. And of course, we could also check whether Python is in the text Python. And that is, of course, again the case because those one are in fact the exact same values. And we could also check if only the letter N is in our text. So this here would work as well. And we can just reverse this by saying not in. And now we will not get ayo because N in fact is in Python. So if you check for N not being in text, you will get false because it is in text. So you have the logical operators and or, the comparison operators that check for equality, inequality, greater than, less or equal than, and greater or equal than. You can also use identity operators, so is and is not, and membership operators, so in and not in. And especially membership operators, comparison operators, and logical operators are super important. Let's now understand the ternary, or also called conditional expression. Imagine we're having a variable x that is going to be equal to 5. Now we could check if x is greater or equal to 10, for example. If that is the case, then we could say that our result is going to be big, for example. If that is not the case, so else, our result is small. And now let's just print our result. And we're getting small in the console because x is of course not greater or equal to 10. Let's turn this to a 10, for example, and now we're getting big. But there's also a much shorter way to write the exact same. We could, for example, create a variable result, and result is going to be equal to big if, and right after this if statement, we now need our condition. So if x is greater or equal to 10, so if that is the case, then we're going to return big, else we're going to return small. So this right here now only takes one single line of code and gives us the exact same result, as you can see. So now we're having big because, of course, this number is big. And if I'm going to use 5, this is going to be small. So the structure is just a little bit different. You have the condition right here. If the condition is true, you're going to return this, or you're going to do this. If the condition is false, then you're just going to do whatever you have after this else statement. So we'll return small in this case, or assign small to the variable result. So this is just a shorter way of writing an if statement. Let's now understand the while loop. The while loop will allow you to do something as long as the condition is true. Let's, for example, create a variable, I for example, and that one could be equal to 0. And now we, for example, want to print something in the console while I is less than 10, for example. And while I is less than 10, we always want to print I. but at the moment, this loop will run over and over again, because this condition will always be true. It's never going to be false, because we're not changing I. In order to break out of this loop, after a certain amount of iterations, we should increment I. So we should, after every single iteration, say that I plus equal 1, for example. So we'll increment I by 1 after every single iteration. So let's execute this code, and you can see in the console we're getting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we'll break out of the loop, because then I is actually equal to 10, so it's not less than 10 anymore. So how does a while loop work? You always start by using the while keyword, and after the while keyword you have the condition. While this condition is true, we will execute the while loop. And after the colon, you always define what you want to do for every single iteration. And in our case, we want to print I, and we want to increment I by 1 after every single iteration. So during the first iteration, I is going to be 0. So we're going to check, is 0 less than 10? 0 is less than 10, so we print 0, and then we'll increment I by 1. During the next iteration, I is going to be 1. Is 1 less than 10? That's of course true. So we'll again print I and increment I by 1. And we do so until we reach the number 10, and then we're going to check, is 10 less than 10? 10 is of course not less than 10, so we break out of this loop. And of course I could also create a different condition right here. So I could also say I plus equal 3, for example. And now we are only outputting every third number. Let's now understand the for loop. The for loop will execute a block once for each element in an iterable. And you do not need to perfectly understand iterables yet, but things like strings are iterables, for example. So we can use a for loop on a string. You start a for loop by using the for keyword. Now we need a placeholder. This could be character, for example. The name is up to you, so this could also be A or ABC or pretty much anything you like. But character is descriptive in our case. And now I'll say for character in NPC, for example, I just want to print the character. And let me show it to you before I'll explain this. You can see we're getting NPC. So we print one character every single time. And a for loop will, as already mentioned, execute a block once for every element in an iterable. And in a string, every single element is a character. So this here is the first element, this is the second element, and this is the third element. So those are all single elements, and for every single iteration, character will hold one of those elements. So for the first iteration, character will hold the element n, so the letter n, and print the letter. Then we go to the second iteration. For the second iteration, character will hold the letter p, print the character p, and then we go to the third iteration, and for the third iteration, character will hold the letter C. So we print C. And there exist a lot of different iterables in Python. As already mentioned, you do not need to understand this yet, but you can also iterate over a list. So this here could be 1, 2, 3, for example, and we're outputting 1, 2, 3. Let's now understand range, continue, and break. You can also use the range to create a series of numbers, and this series of numbers is iterable. Let me show you. So we can use for number, for example. Again, this name is up to us, but number is descriptive. In range, and right here we can define a range. And you can see we can define a start index, a stop index, and a step, for example. We could, for example, say we want to go from index 1, for example, to index 10. And now I'll just print out our number. Let's execute it, and you can see we're getting 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we get all of those numbers excluding the last number, so excluding 10. I can also go up to 100, for example. And now we'll have all of the numbers up to 100, from 1 to 100 to be precise. But now let's go from 1 to 5, for example, like so. Or from 1 to 6, so we'll actually get the 5. And we have all of those numbers. But now let me, right before printing this number, do an if check. So if number is equal to 2, let's just continue. And let me execute this code. And you can see we're getting 1, 3, 4, and 5. But we're not getting 2 anymore. So continue actually means just break out of this iteration and continue with the next iteration. So just jump to the next iteration. And we can also use the break statement, and that one does not continue with the next iteration, but this one completely breaks out of the loop. So we'll only print 1, and once we get to 2, we just break out of this loop. So continue goes to the next iteration, whereas break completely breaks out of the loop. Let's now understand match case. And match case is just a good alternative to an if statement under some circumstances. Imagine we are having the weekday, for example. And weekday could be 1, for example. 1 could be equal to Monday, then we have Tuesday, Wednesday, Thursday, and so on. And now we can check if weekday is equal to 1. And if that is the case, then we can print Monday, for example. If weekday is equal to 2, then we can print Tuesday. And let me just skip the rest of this code so I think you get the idea. And let's just say else print something went wrong. So now I can execute the code. And of course we need a colon right here. So let's execute this, and we're having Monday. 2 would be Tuesday. And 10 would be something went wrong. But you can see the code is pretty long. So let me show you a shorter way. We can just use match right here, followed by the variable name. In our case, we want to check for a match of weekday. And now we can define different cases. So we could have the case 1, for example. So let's have this case, so case 1. And if case 1 occurs, then we just want to print Monday. Now we can define another case, so case 2, for example, and then we just print Tuesday. And as you can see, this here is a little bit shorter than an if statement for this scenario, for example, and a little bit more readable. Let's also create case 3, print Wednesday. So now I added all of those cases, and now we can also create a default case. So in case all of those cases are wrong, so in case none of those cases occurs, we can create a case underline. So this here is the default case, colon, and under those circumstances, we're just going to print something went wrong. And now let's try weekday 1. Let's print this. We're getting Monday. 2, Tuesday. 5 should be Friday. And let's try 7, for example, which should be Sunday. And let's also test 10, which should just print something went wrong. And we're getting something went wrong. So again, you might not use a match case too often, but under some circumstances, it's definitely useful and can be a shorter alternative to an if statement. But I want you to know that you can achieve the exact same result by using an if statement theoretically, but in this case, a match case is a little bit cleaner. Let's understand a couple more important data structures in Python. And today I want to show you lists, tuples, sets, and dictionary. A list is basically just a list, so I can store elements inside of this list. Let me show you. Imagine we're having a list of numbers, and usually you use plural because a list of course holds multiple elements. And this could be 1, 2, 3, 4, 5, and so on. A list is an ordered and mutable collection. So let me print our numbers list for you so you understand it a little bit better. And you can see we're getting this list right here. But now I can also append an element. So I could say numbers.append, for example, and I could append the number 6. If I'm now going to print this again, you can see that we have the number 6 at the end of the list. So I can see this list is ordered, and since I appended a number, it's also mutable. We can also have one element a couple of times, so I can have 5, 5, and so on. And now you can see we have all of those elements inside of our list. To access one of those elements, I can use the index. Since it's ordered, the number 1 will always be on index number 0. So lists also start counting at 0. So this element has index number 0, index number 1, index number 2, and so on. So let me print this, and you can see we're getting number 1. So the number with index number 0. If we want to access the last element, we can use -1. which should be 6 in our case because that has been the number that we've appended to the end of this list. And now we're getting 6. And we could also use number 1, and this would give us this element right here. So the element with index number 1. A tuple is pretty similar to a list. It's also ordered. It also allows duplicate elements, but it's immutable. Let me show you. So we could also have a numbers tuple, for example. And this would now look like this. So you create a list by using those brackets right here, and you create a tuple by using those round brackets right here. And now we could also have 1, 2, 3, 4, and 5, and 5, and 5, and 5, for example. So we can have duplicate elements right here, and this here is ordered as well. So let me print the numbers for you. And we're getting the numbers as well, but this time inside of a tuple. And since this is again an ordered list, I can also access those elements by using their index. And again, index number 0, 1, 2, and so on. So let's access the first element by using index number 0. And we're getting the element 1, so the first element. If we wanted to get the last element, we could use -1, for example. And this will give us 5 because that is our last element. Let's take a look at a set. A set is a little bit different because it's not ordered anymore, it's unordered. It's also mutable, but it only stores unique elements. You create a set by using those brackets right here. And now we could again store numbers inside of the set. So 1, 2, 4, and let's maybe try to add 5 twice. Let me just print out numbers again. And now you can see instead of this numbers set, we are having the number 1, 2, 4, and 5. But we only have the number 5 once, even though we've added it twice right here. So every single duplicate element will just get removed when using a set. And this is really good if you iterate over something and want to check whether something already exists, and you only want to add it if something does not yet exist. Because then you just add it to the tuple. If it's a duplicate value, it will get removed anyways. And otherwise, it will get added to the set. But now, since it's also unordered, I cannot really access the elements like this. So I'm getting a type error because object is not subscriptable. So of course, if it's unordered, there does not really exist an index of 0 because we of course do not know the order. But we could add a number to a set. So we could say numbers dot, and in this case we have to use the add method. And now we could, for example, add the number 6. Since we do not have the number 6 yet, this should get added to our numbers set. Let me print this, and you can see we're now having 1, 2, 4, 5, and 6. If you wanted to access all of the individual elements, you could use a for loop. So I could say for number in numbers, print number. And this will just iterate over this numbers set and output one number after another. So 1, 2, 4, 5, 6. And that would be a way to output all of the numbers without accessing their index. So sets are unordered and only store unique elements, but they are also mutable, similar to lists. Let's also take a look at a dictionary. And a dictionary allows you to store key-value pairs. So you map a value to a certain key. Imagine a social media app where we have a user, for example. In this case, a dictionary could make sense. So we could create this user dictionary. Now we define the key by using quotation marks, and instead of those quotation marks, we define a name for the key. So maybe username, colon, and after the colon, we define the value for the key. So the value for the corresponding key. And that one could of course be NPC, because that might be my username. Now this user might, for example, also have an IQ, and the IQ might be 25. So pretty smart. And now let me just print out the user. And we're getting this dictionary in the console. We can access one of the values of this dictionary by using the key instead of brackets, for example. So maybe I want to access user of username. So the username of our user. And we're getting NPC in the console. So you can access the individual values by accessing the dictionary followed by brackets, and instead of those brackets, you just define the key. And we can, of course, also access user of IQ. And now we would get my IQ of 25. If you wanted to add a new key to our user, you can do so by using the key as well. So, user of biceps size, for example, is going to be 18. So you add a new key value pair by using user. Inside of the brackets, you define the name of the key. And after the equal sign, you define the value. So let me just print the user for you. So you see that this in fact works. And now we're having a new user dictionary. And we have username, IQ, and bicep size. So to summarize, a list is ordered, it's mutable, and it allows duplicate elements. A tuple is ordered, but in comparison to a list, it's immutable, but it also allows duplicate elements. So list and tuple are ordered and allow duplicate elements, but list is mutable, whereas tuple is immutable. A set and a dictionary are both unordered in comparison to lists and tuples. Both of them are actually mutable as well. And a set can only have unique elements, whereas a dictionary can only have unique keys. So you can't have duplicate keys for a dictionary, of course. And that's all you need to know about lists, tuples, sets, and dictionaries in Python. Let's now understand a couple important methods for lists. If you remember, lists are ordered, they are mutable, and they are allowed duplicate elements. Imagine we're having the list nums, and the list num can be equal to 4, 3, 2, and 1, for example. To append an element, I can use the list name, so nums, followed by dot append. So this will call the append method of our numbers list. And now we can just define the element we want to append. So a 10, for example. Let me now just print our nums. And I'm going to print this. And now we have a 10 at the end of our list. So append adds an element to the end of our list. I can also use the method pop, so dot pop, followed by those brackets. I'm going to run this. And now pop removes the last element of a list. In our case, number 1. We can also use len to get the length of our numbers list. So we're going to use len, opening and closing brackets. And inside of those brackets, we pass our nums list. Let me execute this. And you can see we're getting 4 because at the moment we have 4 elements. And we can also sort our list by using the sort method. So nums.sort, and this will just sort this list. So let's just print our nums. And we're getting 1, 2, 3, 4. Let me also add a 10 right here and a 2 right here. So you see that this here works. And now we're getting 1, 2, 2, 3, 4, 10. So it sorts them from small value to bigger value. Also, up to this point, we've always used numbers, but I want to make sure that you understand that this can be pretty much anything. This could also be a list of animals, and now we could store a monkey inside of this list, a giraffe, an elephant, and so on. So you do not need to use numbers only inside of a list. You can store pretty much anything inside of a list. And now I can print animals, for example, and animals of 0, for example. So I will get the monkey. So this works the exact same. And I can also use mixed data types right here. So I can also output true, for example. And this here should work fine as well. Let's now take a look at the most important tuple methods. A short reminder, a tuple, like a list, is ordered and allows duplicate elements, but it's immutable, so you can't add or remove elements later on. Let's now, for example, create a students tuple, so you understand that this is also not limited to numbers only. And the students array could now hold the names of students. First student could be Jonas, for example. Second one could be Jenny, Joseph, and so on. And now we can, of course, start by printing the students, and actually this needs a T right here. And now I can just output the students, and we're getting them as a tuple. I can now also output the length of this tuple, so the amount of elements inside of this tuple, by using len, similar to lists, of students. And this will output 3 because we have 3 students. We can also count the occurrence of a certain value inside of a tuple by using the tuple name, so students dot count, so followed by the count method. And now we have to pass the value we're looking for inside of those brackets. Maybe Jonas. And you can see we're getting 1 because we have Jonas once. But we can also add Jonas a couple of times here. And now let's add it 4 times. And now we're getting 4 because we have Jonas 4 times. And we could also get the index of a certain value. So maybe index of Jonas. And this is going to be 0 because the first occurrence of Jonas is at index 0. If we pass Joseph right here, we would get 2 because Joseph has index number 2. And let's just pass some random string in there. And now we would get a value error because of course this here does not exist. So X not in tuple. And again, for tuples, you can also use different data types. So I could also add a number right here and false. Let me introduce you to a couple of important methods for sets. Again, a short reminder, a set is unordered, it's mutable, and it stores unique elements. And especially the last part, so a set storing unique elements is important. Let's create a set of numbers. So numbers is going to be equal to a set of 1, 4, or 3, 4, 5, and 7, for example. Now we can add an element by using the name of our set, so numbers dot add. And now let's, for example, add the number 10. Let's now print our numbers. And we're getting our set in the console. And you can see we've added the number 10 to the end of our set. So add will add an element to the end. We can also remove an element from a set. And since all of those values are unique, we only have to pass the value in here and it will remove the element with the given value. So now we've got 1, 3, 5, and 7, and 4 has been removed. We can also output the length of a set by using len, followed by the name of the set, so numbers. And we're getting 5. And we can also check whether a certain value is in our set or not. And we can do so by using the value. So let's maybe check for 2. And let's check whether 2 is in numbers. And now you can see that we're getting false, so 2 might not be in numbers. 1 should be in numbers though. So right now we're getting true. And for sets, it's technically possible to also have strings right here or different data types like true, so booleans and so on. But for sets, you should definitely try to avoid this. So this is something you definitely do not want to do for sets. Let's now take a look at the most important dictionary methods. A short reminder, a dictionary stores unordered key value pairs, and the keys have to be unique. So values can of course be duplicates, but since you access by using the key always needs to be unique. So let's stick to our old example and let's just have a user, and inside of the dictionary we define a username as a key, and the username is going to be NPC, and now he also has an IQ of 25 again. We can now get the length of this dictionary by using the len property. So print len of user. Let me output this. And we're getting 2 because at the moment we have 2 key value pairs. If I now add a third key value pair, so for example speed of 10, then I would have 3 key value pairs. To now access a certain value inside of my dictionary, I can use the bracket notation similar to before, so user of username. And this will output the value for username, but I can also use the get method. So .get followed by the key right here. So maybe user.get of IQ. And this will output the IQ in the console. I can also use the keys method to get all of the keys. So let me show you. User.keys. And now we're getting those keys inside of this list. So username, IQ, and speed. And this can be pretty useful for a for loop, for example. So I can say for key in user.keys, colon. And now let's just print the key. Because this here returns an array, and for every single iteration, key will now hold one of the keys. So in the first iteration, key will hold the value username, second iteration IQ, third iteration speed. And we're just going to print out the key for every single iteration. And you can see we're getting in the console username, IQ, and speed. Now let me remove this and let me print out user.values. So similar to the keys, you can also get the values. And we're getting all of those values inside of this list. So I can use user.keys to get all of the keys inside of a list. And you can use user.values to get all of the values inside of a list. And of course, you can also use a for loop now, once again. So for value, for example, in user.values. And now I can just print the value. And now we're getting the value MPC, 25, and 10. So all of the values for our dictionary. If you want to get values and keys, you can use user.items, for example. And now we're getting this list right here that includes a couple for our key value pairs. So one tuple for every single key value pair. So username MPC, so this is the key, this is the value. IQ 25, so this is the key, this is the value, and the same for speed of 10. And now we could get key and value within a for loop, for example, by saying for key, comma, value. So key, first element, value, second element, in user.items. And now we can print the key, for example, and the value, and we would get our key value pairs. So username, MPC, IQ 25, speed 10. And of course, we can also format that. So let's use a formatted string, f, and say the key is value, for example. So the username is MPC, the IQ is 25, the speed is 10. So the dictionary name followed by .keys gets you the keys, the dictionary name followed by values gets you the values, and the dictionary name followed by .items gets you key value pairs. Now let's also add and update a key value pair right here. To add a new key value pair, we've already seen this, you just use the dictionary name followed by those brackets, and inside of those brackets you define the new key that you want to add. So for example, hobby, and user of hobby is going to be equal to coding, for example. I'm just going to print our new user right now, and we're getting a user NPC who has now the hobby coding. We could also update a certain property by just using user of speed. So we just define the name of the key once again, and now we can define a new value. So maybe our speed is 100 right now. Let me print the user, and you can see we now have a speed of 100. So to add a new key value pair, you just define the name of the key, followed by the value to the right, and to override it, you just define the name of the key as well, and just define a new value. So this is pretty simple. I also want to make sure that you understand that within a dictionary, you can also have different values. So I could have, for example, your key hobby right here, and as a value, you can also pass more complex data structures. So I could have a list right here. So maybe you have a hobby of coding, soccer, gym, and so on. And of course, you can also have a dictionary inside of a dictionary. So maybe if you think about a user, you have friends within your app, and then friends right here could be a list, for example. And inside of this list, we store all of our friends as dictionaries. So we could again have a username of Peter, an IQ of 140. Actually, let's close this right here. And now we could just copy this one and have a couple of friends in here. So that could be Mary and so on. So I think you get the idea. So I really want you to understand that when using lists, tuples, and dictionaries, you're not limited to one single data type. You shouldn't do this for a set because this can cause a lot of problems, but for the other ones, this is totally fine. And that's all you really need to know about dictionaries in Python. Let's understand iterables and memberships. An iterable is an object you can iterate over, and we've already seen a couple of them. One example is a list, for example. We can iterate over those objects by using a for loop. So for, let's for example say num in, and now an example for an iterable would be a list. So 1, 2, 3, 4. And now we can just print num. Let me execute this, and you can see we're getting all of the numbers in the console. So a list is an iterable. A tuple is also an iterable. So 1, 2, and 4, for example. Let me execute this, and now we're getting 1, 2, and 4 in the console. A set would be another option. So 1, 2, 3, and 4. And this works as well. A string works as well. So a string in Python is also an iterable. So this is some text, and now we can iterate over this text. And this works as well. And of course, range is an iterable as well. So range 1 to 11, for example. So now we're getting the numbers from 1 to 10. So if you can iterate over it, it's an iterable. There exist a couple more, but those ones here are the most important ones. And for most of those iterables, you can also check for membership. So let me print, for example, whether the value 1 is in a list of 1, 4, and 10. I'm going to execute this and we will get true, because of course the value 1 is in the list 1, 4, and 10. 2 would of course be false because it does not exist inside of this list. And the same also works for a tuple again. So we can replace this list with a tuple, and this works as well. So 2 is false, 1 is true. Same works for a set. So let's replace this with a set. And we're getting true again. For 5 we would get false. And we can of course also check for text. So hello in hello grade course. Let me execute this and we're getting true. And like this, we're getting false. And of course, you could also check whether this is not in. And now we would get true because of course, this string is not in hello grade course. So an iterable is an object you can iterate over, and membership are objects you can check membership within or not in. Let's take a look at list comprehension in Python. Imagine we're having a list of numbers. So numbers is equal to an array. And maybe this array holds the numbers 1, 2, 3, 4, and 5. And now maybe we wanted to create a new list, and this list just contains all of the doubles. We can do so by creating a new variable, doubles, which is going to be equal to a list. And now we can just use a for loop inside of this list to iterate over those numbers and double them. So let's start by creating a for loop. For, now we need a name, so for num in numbers. So this is just a normal for loop that we'll use to iterate over the numbers, and this num is again going to hold one of those numbers for every single iteration. And when using list comprehension, right before the for loop, you define what kind of value you want to store within this list. So we could, for example, say that we want to store the value of num times num for num in numbers. So this is how this works. And now let me just print the doubles right here. And you can see we're getting 1, 4, 9, 16, and 25. And actually this is not even a double, so num times 2 would be the double. So that was my bad, guys. And now we should get the doubles. But of course the logic right here is up to us. So you could also do num times num, or you could do num times num times num. So that is up to you. And now we would get 1, 8, 27, 64, 125. So right here you define the number that you want to store within this new list. And right here, you define the for loop. And now, right after this for loop, you could also use an if statement if you wanted to. So you could, for example, say if num is less than 4, for example. And I'm going to execute this. And now we'll only get 3 numbers. So right here, the number that you want to store, loop, and a possible condition. And that is how list comprehension works in Python. Let's understand functions in Python. Functions are reusable code that runs when called. Imagine we wanted to print out the username, and maybe we want to say, hey, NPC, it's nice to see you right here. And maybe we want to call this here a couple of times. So maybe for every different user, we want to call this print statement again. So of course, we could also say that this here is an F string, and we have a name right here. And now our name is going to be equal to Jonas. And maybe we want to execute this code a couple of times, for example, and so on. And this here is a super simple example. But you see, even at this point, it's already a little bit of code. And it's always pretty much the same logic. So under those circumstances, we can define the function once, and then only call the function when we want to run the function. To define a function, we use the def keyword right here. So this here defines a function. Next up, we can define a name, and this name is up to us. So this can be anything, but descriptive names might make a little more sense. So I'll call this function greet, for example, because it should greet the user. Now we have those opening and closing brackets, followed by a colon. And after this colon, we define the code that we want to execute within this function. And at the moment, let's say we just want to print hello, for example. So we'll just greet the user. So this here is the function definition. If I'm now going to run this code, nothing is going to happen because at this point we only defined the function. We never called the function. So in order to execute the function, we have to call the function. And we can do so by using the function name followed by opening and closing brackets. And let me now execute this code. And you can see we're getting hello in the console. So this works. And if I now want to do the exact same thing again, then I can just copy and paste this line in here a couple of times. And this will execute this function block over and over again. So in this case, for example, 4 times. So I only have to define the function once. And then I can always use it over and over again. And especially if the logic becomes more complex, you can imagine that this here is a lot shorter than writing probably 10 or even hundreds of lines of code over and over again. Now, of course, at this point, it's probably not the most useful thing to do because we just print out hello over and over again. And this is not really flexible. And in order to change that, we can use a parameter. So let me change or delete the name right here. And now we can accept a parameter right here in those brackets. So you define all of the parameters inside of those brackets. You can make up the names yourself. So it could be a name. It could also be this. Doesn't matter. But name is more descriptive, so we use name. And we could also use a couple of different parameters. So age, for example, height, whatever. That's up to us. So you can define as many parameters as you like. And now by defining those parameters right here, you say that you accept them as arguments within those brackets when calling the function. So our name could be Jonas right here, and our age could be 24. Let me delete those ones for now. And at the moment, if I'm going to run this function, we're still only getting hello. Because right here, we're only accepting the parameters, but we're not using them at this point in time. I could, for example, use an f string, and now I could say hello, name, and now we would already get hello Jonas. You are age, years old. And now let me do this. Hello Jonas, you are 24 years old. So to just sum it up, when using a function, you always use the def keyword to tell Python that you now want to define a function. Then you give this function name, followed by parameters. You say that you will expect those parameters when calling the function later on. So you say, when I call this function, I will pass an argument. And when you define it right here within your function definition, you call this parameter. And when you pass the specific value, it's called an argument. And that's just the language that programmers essentially use. It doesn't really matter for you. So this here is pretty much the exact same. So this here is just a placeholder for the value that you'll pass later on. And it's pretty similar to a variable if you think about it like that. So right here is the variable definition essentially. And this here is the actual value that will pass to this variable. And in programming, we call this variable parameter and the value argument. And now you can just use those parameters within your function definition to, for example, output the name, to output the age, or to do pretty much anything. You could also define a function to calculate the sum. So we could say def sum. We could get a value num1 and a value num2, so 2 numbers. And now we can just print num1 plus num2, for example. So the logic is up to us. And now I can just call the sum of 10 and 20. Let me run this code. And you can see we're getting 30 in the console. I could also say the sum is colon, comma, like so. And now we would get the sum is 30. And now it's pretty nice about the function that we could just call the sum once again. And we can use different arguments right here. So we could also use 50 and 50. And now we have the sum is 30 and the sum is 100. And I can also call this function once again. Now for maybe puzzle, he's 98 years old or 984, doesn't matter. And now we're getting hello puzzle, you're 984 years old. And that's pretty nice about a function. You define the functionality once, and then you can use it over and over again and adjust it to your needs by passing the actual values. Let's now understand the difference between return and print. Imagine we are having a function, sum for example, and this function sum takes a parameter num1 and a parameter num2. And now we are just going to print num1 plus num2, for example. Let me now call the sum of 10 and 20, and this will output 30 in the console. And you can see we're getting shadow built-in name sum, so I can also use get sum right here, and this should fix the problem, or the warning at least, and we're still getting 30. And at this point in time, we are just saying that we want to print num1 and num2. So we'll print the number and we return none. But maybe we want to do something else with the returned number, and that does not work in this case. So if I, for example, wanted to create a new number that is going to be equal to, for example, 20 plus get sum, and I pass 20 and 20 right here, so this should be 40. This does not really work because we're just printing the number at this point. So I can see this does in fact not work. And under those circumstances, we can also return a value. So return says that we want to send the value back to the caller. So let's return num1 plus num2. And now this here does not throw an error anymore. And we can also print the number right here. And you can see that this here is completely fine, because at this point in time, we return the value. So we can use the value for pretty much anything. We could, for example, also just store the value of getSum of 20 and 20 in our number variable right here. And later on, we could create a number 1, and that one is going to be equal to 40 plus number. Now I could also say number 2 is going to be equal to 60 plus number, for example. And now let me print number 1, and let me also print number 2. And now we're getting 80 and 60. So returning the value is especially useful if you want to store the value or use the value later on within your code. And oftentimes you want to store the value somewhere. And under those circumstances, you want to use return. So print only outputs the result in a console, whereas return allows you to later on use this result wherever you like. And something that is important about the return keyword, let me also try to print right here, hey guys. And now let me actually just call getSum. So getSum of maybe 20 and 40. And let's remove those print statements as well. And if I'm now going to run this, you can see that we're not getting anything. Let me put this right before the return keyword though. And you can see now we're getting hey guys. So once a function reaches the return keyword, it returns the value and stops executing. So everything that comes after the return keyword will not get executed. And that is something that can be pretty useful under some circumstances. So let me first of all delete all of this. And imagine you want to register a user. So this you could be register, for example, doesn't really matter. And now you could expect a password. And now you could check if not password. So if the password is essentially empty, because if you remember, an empty string is equal to false. So then we will not have a password. And under those circumstances, you could just return, for example. And if we have a password, for example, we could keep execution, and we could also check for an email, for example. So if not email, we could also say, let's return. And now we could just have some code right here to create the user essentially. And after we created the user, we could, for example, say, return the user. And of course, we do not have this right here, but this is just a minimalistic example to show you how you can use return, for example, and why it is important. Let's understand default arguments. So imagine we are having the greet function once again, so def greet, and we'll expect to get the name later on. And now we're just going to print an f string that says, hey, name. So we're just going to greet the user. So let's just execute greet. Let me run this, and you can see we're getting this error because we have one missing required positional argument. But maybe we do not want to pass a value right here. And under those circumstances, we can also use predefined values, so default arguments. And we can do so by just using an equal sign and define a default value. So maybe we are just going to use Lily right here. And of course, in this example, it does not make too much sense, but I want you to understand the purpose of default arguments. So let's run this now. And now we're getting hello Lily. So we do not have to pass an argument right here when calling the greet method. But we can do so. So we could say Peter. And now we're getting hey Peter. So if we pass an argument when calling the function, we will use that argument, and otherwise we're just going to use the default argument. So I could also have one call where I pass Peter and another call where I just do not pass anything. And now we're getting hey Peter and hey Lily. and those are default arguments in Python. Let's now understand keyword arguments, and those are arguments passed by parameter name, not by position. If you think about the greet function, and we'll have a name and an age, for example, we have positional arguments, because later on, when we're calling the greet function, so let me just print name and age, doesn't matter too much. So later on, when I call the greet function, the first argument, as you can see, is my name. So I have to pass a name right here. And the second one is going to be the age, so 28, for example. If I'm now going to run this, you can see we're getting name and age right here. If I reverse the order, so if I use 28 for the name, that of course doesn't make any sense. But I could execute this technically, but the result would of course not be what we're looking for. So if you want to get the result you're looking for when using positional arguments, they always have to be at the right position, like so. So name needs to come first and age needs to come second, but we can also use keyword arguments. And we can do so when calling the function. So we can just say, for example, that age is going to be equal to 29 and name is going to be equal to Jonas, for example. And now let me print this in a way that makes a little more sense. So let's use an F string. Hey, name, you are age, years old. So let's print this. And you can see we're still getting the same result. So hey Jonas, you're 29 years old. If this would be a positional argument though, so let me show that as well, then the result would be pretty weird. So let me delete name, let's run this, and we're getting hey 29, you're Jonas years old. And of course that doesn't make any sense. So if we wanted to keep this order, we would have to use keyword arguments, like previously. So age 29, name Jonas. And now this works just fine. But I'm going to be honest, most of the time you'll be fine using positional arguments. Let's now understand args and kwargs in Python. In order to access args and kwargs, we should first define a function, so def get sum, for example. And now we can say that we expect args by using an asterisk followed by the args keyword, like so, colon, and let's for now just print the args. And if you take a look at the definition, args collects extra positional arguments into a tuple. So let me, for example, try to get the sum, so get sum, of maybe 5, 10, and 25. And as you can see, the code editor already shows us that those right here are args. So let me run the code, and we're getting 5, 10, and 25 inside of a tuple. So args are just positional arguments, and we will get all of those positional arguments inside of this tuple. And now we can of course use this tuple, for example, by using a for loop. So we could say for arg in args, for example, and of course this name is up to us, could also be num. And let's now, for example, create a variable total that will keep track of our sum. So total, let's initialize that one with the value 0. And now we just increment total by num. So total plus equal num. And during the first iteration, num will hold the value 5. So we'll add 5 to total. Second iteration, we'll add 10 to total. And third iteration, we'll add 25 to total. And now instead of args, let's just print total after the for loop. So print total. And now let me just execute this code right here. And you can see we're getting 40. So args allows you to use positional arguments. We can also get kwargs though. So comma, asterisk, asterisk, kwargs. And for now, let's just print our kwargs as well, like so. And let me also just remove all of this right here. So now let me try this. And you can see we get this empty dictionary. So we don't have any values yet. And the reason for this is that you use kwargs to collect extra keyword arguments into a dictionary. So args for positional arguments and kwargs for keyword arguments. So we could, for example, say name equals Jonas. Now we can run this and we have Jonas inside of this dictionary. We could also add an age of 101. Let's do this, and that's what we're getting. And now we can of course also iterate over kwargs. So we can also use a for loop right here. So for value, for example, in kwargs. And since this is a dictionary, we can of course use dot values, so the dot values method right here to get all of the values, colon, and for now let's just print the value, for example. Let me execute this code, and you can see we're getting Jonas and 101. Of course, since Kwargs holds a dictionary, we could also say key, value in Kwargs.items, for example. And now I could, for example, print key and value. And when I execute this, we're getting name, Jonas, and age 101. And I'm going to be honest, I've never really used Args and Kwargs, but frameworks oftentimes use them under the hood, so it's good if you at least understand the concept. Let's take a look at scope in Python. And scope in Python starts local, goes to enclosing, global, and built-in. And let's do an example so you really understand how this works. Imagine we are having a variable name, for example, and this name is going to be equal to Jonas. Now let's also define a function, and this function could have the name outer. And inside of this function, let's just define another function, and that one is going to have the name inner. So we have an inner function in the outer function. And within the inner function, let's now also define a new name variable, so name being equal to Jenny, for example. And now let's just print the name right here. And let's also call the inner function right after defining it. So inner right here. Now right before defining this inner function, let's also define another name. So let's create the variable name right here in the outer function as well. And name is going to be equal to Mary. And now we're just going to call outer right here. So we call the outer function, and inside of the outer function, we call the inner function. So at the moment, we are just executing this function right here. So we're setting the name to Jenny and we're printing the name. But we have the name a couple of times right here. So we have a global name variable, we have an enclosing name variable, and we have a local name variable. So let's see what Python will print. And you can see we're getting Jenny. So we're getting the variable within the inner function. And the reason for this is that local will always come first. So Python will first look within the closest scope. Now, if we're going to remove the variable Jenny right here, it will not find the variable within the local scope anymore. So it will get to the next closest scope. The next closest scope is the enclosing scope. So this one, because this function right here is enclosing the inner function. So let me play this so you see this works. And we're getting Mary. So it takes a look at the enclosing scope. But if the enclosing scope does not exist, it will next take a look at the global scope. If the global scope does exist, it will print the name. But let's also remove the global scope right now. And now it will take a look at the built-in scope. So is this variable actually built in? And since it is not, we're getting this name error. Name is not defined. So let me now also use a variable that is defined. So that is built in. And that is, for example, len. So let me say len is equal to global right here. Now, right here, we will have len being equal to enclosing. Right here, we have len being equal to local. And now let's just print len. Let me run this. And you can see we're getting local. Let me remove this. Now we should get enclosing, because this should be the next place to look. So we're getting enclosing. Let me also remove it right here. Now we should get global. So global right here. And let me also remove global. And let's print this. And you can see we're getting built-in function len. So when it comes to scope, local before enclosing, before global, before built-in. But actually I think this is also pretty intuitive. So it's nothing you really have to think about too much. Let's now understand modules and imports in Python. So a module is just a Python file that contains reusable code. And you need to use an import to import those modules so I can use them. So I can't use a module within your file without importing it. And we've already seen an example of a module, and that was the math module. And if you remember, we get access to the math module by using import followed by the module name. So import math. And now after importing it, we have access to the math module. So we can, for example, print math, and now we can access a couple of math methods. So I could, for example, get pow and raise one number to the power of another one. So maybe 2 to the power of 4. And I'm going to run this, and we're getting 16.0. And the reason that this works is that this function right here is defined within the math module. So someone defined the function inside of this module. We are importing this module, and now we can access all of the functions that are defined within this module. And something that is really important is that you can also create your own modules. And what exactly is a module? A module is basically just a Python file. So we can just say new. Let's create a new file. And that one has the name utils, for example. So utils.py. And now let's say a utility function that we want to create is the greet function. So def greet. And right here, we're just going to print hello bro, like so. And now let's go back to our main.py file and let's import utils. So we can also import this file right here within our main.py by saying import followed by the name. So import utils. And now we can just access this greet function right here by using the module name. So utils.greet, for example. So now we're accessing the greet function from the utils module. I'm going to execute this, and you can see we're getting hello bro in the console. So modules are super useful because you can split your code into separate files and access all of the files within your main file, for example, or pretty much within any other file. And that's of course up to you. And that's especially important for bigger projects because you can imagine once you start writing maybe thousands of lines of codes, you really start to lose track of what is going on if you do not logically split your code across different files. So you could have files for helper functions, you could have files for connecting to a database, you could have files for creating math functions, for example. So that is up to you. And that is all you need to know about modules and imports in Python. Let's understand if Dunder name equals Dunder Main. Again, let's imagine that we have another file. So let's create a new file. That file can again have the name utils.py. Let's create that one. And let's again just create a function, and that function could have the name greet. Again, let's just print hello. And now you can see if I'm just going to call the function right here, like so, and I'm going to execute this file, we are printing hello in the console. If I'm now going over to the main.py file and I'm importing my utils and I'm going to execute the code, you can see we're also getting hello in the console. So once we're importing this utils module, we are also executing the entire file. So we're getting access to all of the methods, but we're also executing all of the methods that we're calling within this file. And oftentimes that is something that we do not really want to do. And in order to fix that, we can use if Dunder name equals Dunder Main. Let me show you. So let's create an if statement. And if Dunder name is equal to quotation marks, Dunder Main, like so, colon, only then we're going to call the greet method. So let me actually execute this file right here. And you can see we're again getting hello in the console. So nothing really changes. But let me now execute the main.py file again. And let me show you what happens. And you can see our console is completely empty. So Dunder name equals Dunder Main means only execute all of this code that comes right here after the colon if you directly execute this file. So if the file that we're executing is utils.py, so this file right here, then execute this method right here. If we're calling this utils.py from another file though, so if we're executing our main.py and just importing utils, then do not execute the methods that come after this statement. So in short, if Dunder name equals Dunder Main ensures that code only runs when the file is executed directly. Let me introduce you to exception handling in Python. Imagine we are having a variable x, and that one is going to be equal to an integer. So let's cast this to an integer, and we'll try to cast abc to an integer. Let me execute this program, and you can see we're getting value error. Invalid literal for int. So obviously a text cannot be converted to an int. And right here, this here crashes the entire program. So even if I would have a print statement right after, so this here should come right after, you can see that we're never executing this print statement right here. So once we get to this error, the entire program crashes and stops from execution. And in most apps, you of course do not want this. If an error occurs, you want to catch this error and keep executing your program. And in order to define error handling, you use a try block, so try, colon. Right here, after the colon, you define what you want to try. In our case, we want to try to assign this integer to the variable x, or this casted text in this case to the variable x. And if this does not work, then we have to catch an exception. We can do so by using an except block followed by the specific error. So value error in our case. So except value error. And right here we can now, after a colon, define what we want to do in case this here does not work. So in case we're getting an error. And in that case, let's just print you are probably dumb. And I'm going to run this. And you can see we're getting you are probably dumb. And we're also getting print right after. So we're printing right after. So even though this here is obviously not valid, our program keeps executing and just shows the user a warning, for example. Now, of course, we could also get another error. So we could say nums is equal to a list 1, 2, for example. But now let's try to access nums of 5. So obviously that index does not exist. So let's take a look. And let's actually also take this and place it right after. Let me execute this. And you can see we're getting a new error. Now we're having an index error, list index out of range. So before getting to the error that we're actually catching, a new error occurs. So index error. So now we can also catch an index error. So except, let's copy that error, except index error. Under those circumstances, we probably want to print you are dumb for sure. Now let me execute this and we're getting you're dumb for sure. So if this here goes wrong, we are catching the index error. If this here goes wrong, we're catching the value error. But now we could of course also divide by 0. So we could also say y is equal to 10 divided by 0. Let me run this. And we are getting 0 division error, division by 0. And of course we could catch it the exact same way, but we can also just catch all of the other errors by using except right here, exception as e, for example. And this here is just going to be an exception object that we can use, for example. So let me show you. We could just print dumb for sure. And now let me execute this and we're getting dumb for sure. So we're just catching all of the other exceptions. So in our case, division by 0. Of course, we could also catch division by 0 right here, or 0 division error. But this here will just catch every other exception. So every possible exception that could occur. And now let me also print this exception object right here. And you can see we're getting division by 0. So we're getting an error message. So you could, for example, display this error object to the user to give him a little more information. Now after the except blocks, you could also have a finally block. And that finally block will always be executed no matter whether this works or you get an error. So this will always be executed. Let me print, you did it. And let me also remove right after. That's unnecessary for now. And I'm going to execute this and we're getting you did it. So right after catching this error, we are printing you did it. So we're executing the finally block. And now let me also just remove those errors. So let's, for example, divide 10 by 5. Let's print y, for example, doesn't really matter. And you can see we are getting 2.0 and we're also getting you did it. So finally block will always execute. To sum up, you put all of the code that you try to execute into the try block. You catch all of the exceptions, either by name or as a general exception in the except blocks. And you could add a finally block if you want to do something no matter the outcome. So no matter whether you get an exception or it works. Let's understand how to read and write files and also append to files. In order to understand reading, let's first of all create a new file. So let's go to new file and let's create a text file, for example. So maybe heroes.txt. And let's now just add a couple of heroes right here. So maybe Saitama, Goku, Vegeta, and so on. Doesn't really matter. And now let's try to read the text from this file within our main.py file. In order to do so, you should always start by using a with, like so. And this here means after opening the file and doing whatever we've defined, also close the file. So this just makes sure that the file will also be closed. So this is important for performance. Now we can use open right here. And instead of brackets, we now have to define, as you can see, the file. And we can also define a lot of other stuff. But first of all, we need the file. And of course, the name of the file is going to be heroes.txt, so heroes.txt. And as a second argument, we can define the mode. And in our case, we want to use read because we want to read the file. And for read, we use R. Now we can use ns. And right here, we define the file name. So we want to get this heroes.txt as file, for example. Colon. And right here, we can now define what we want to do with this file. And in our case, we want to read this file. So we can use file dot, and now we can call the read method on this file object. So file.read. And this will get us all of the content. So we can also store this content within the content variable right here. And now let me just print the content for you. And you can see we're getting Saitama, Goku, and Vegeta in the console. So this is how you read a file. But now let me also show you how to write a file. In order to do so, we again use with open. Again, we need the file name. So heroes.txt. And all of this is the exact same. The only difference is right here. Instead of R for read, we need to use W for write. And again, we want to save this as a file. So you see the structure is the exact same. And now we can use file dot followed by the write method in this case because we are writing to the file. So file.write. And now we can, within those brackets, define the text. So maybe we'll just add hey right here. Let me execute this. And you can see we're not seeing anything in the console because we didn't print anything. But if we now go to our heroes.txt, you can see that we only have hey right here. And we're also not seeing our heroes anymore. And the reason for this is that file.write will always overwrite the entire file. So if I'm now going to add OK, and I'm going to execute this once again, you can see that hey is now gone. So file.write will overwrite the entire file. If we want to change that, we can use append, and for append we use na. And the rest can literally stay the exact same. So I can now just execute this, and I can execute this a couple of times if I want to. And now let's go to our heroes.txt, and you can see we have OK pretty often. Now we could also create a new line right here by using a \n for a new line. And now I can execute this once again, and you can see now we're getting the character in a new line. There also exists R+ though, so now we can read and write. So we can first use file.read, for example. We can store that within our content variable. And we can now print our content, for example. But afterwards, I could also write. So I could use file.write. And right here, I'll add Saitama right now, for example, within a new line. So let me execute this. And you can see we're first reading the file. And afterwards, we are writing to the file. So after every single execution, I see one more Saitama right here. To summarize, you always use with open, followed by the file name within those brackets, followed by the mode. So either reading, writing, appending, or R+, which stands for read and write. Then we store that as a file. Oftentimes you also see SF. So this is just a little bit shorter and also means file. And then you have to use f.read right here. And right here, so right after the colon, of course, you define the logic. So whether you want to read, write, and so on. And that's how to read, write, and append to files inside of Python. Let's now understand how to work with JSON and CSV files. Let's start by writing and reading JSON files. In order to do so, we first need to import the JSON module. And the rest is actually pretty similar to before. So we again use with open. Instead of the brackets, we need to define a file name. So let's in our case, for example, say users.json. And for now, let's start to write into that file. And again, we say sf. And f again for file. To now write into a JSON file, we have to use JSON, so this module right here. And we have to access the dump method. So that one writes into a file. And right here, as the first argument, we now have to define the JSON text, if you want to say so, that we want to write into the file. So let's use those opening and closing brackets. And we just define normal JSON right here. So username, for example, could be Mary. And we could also define an age of 28 years. Now I also, as the second argument, have to define the file into which I want to write. And in our case, I want to write into this file right here. So we just define f. Now I'm going to run this, and you can see it creates this user.json file. So this JSON file, let me open that one, and you can see instead of this JSON file, we now have our username Mary and our age 28. Now of course we can also read this JSON file, so let me do so. Let me just create with open, I'm going to define a name, so users.json, and right here I'm going to use nar for read as f. And now instead of json.dump, we have to use json.load. What exactly do we want to load? We want to load our file. So we pass f as an argument right here. And now I want to store this somewhere. So I create a content variable, which is going to be equal to json.load. And now I'm just going to print the content. Let me do so. And you can see we're getting this JSON output in the console. So we're getting what we've previously written into the JSON file. Let's go back. So whenever you want to use Python to create JSON, you can do it like this. But now you can also use Python to create and read CSV data. And CSV stands for comma separated values. And you often open CSV files using Excel. So you basically have rows and columns. And that's why you also use Excel to open it, because if you think about Excel, Excel also has rows and columns. So CSV works perfectly with Excel. But now let's take a look at how to create it. Again, to create it, we also have to say with open. We have to define a file. Let's just say this is going to be our test.csv file. Let's first write into that CSV file, and again as f, like so. And for a CSV file, we first have to import the CSV library, so import CSV. And now we have to start by creating a writer. So when you want to use CSV, you first have to create a writer that allows you to write a CSV. So we say csv.writer to create a writer object, and right here we have to pass our file. So right here we define into which file we want to write. And this here returns a writer object, so let's store it as a variable, writer. To now write a row, we have to use writer and call the write row right here, so the write row method. And we have to pass a list right here, and we can just enter the comma separated values. So this could be Max, Jenny, Adam, NPC. To now write another row, we can also use writer.write row once again. And this will now create the second row, like so. So this here could be Susan, Peter, Wolf, and maybe again Adam, doesn't matter. So now we have two rows, and every single row has 4 columns under those circumstances. So Max is the first column, Jenny, Adam, and NPC. But let me just show it to you. So let's execute this code, and you can see this worked. So now we created this test.csv, and we're having those comma separated values. And now let me actually also open that file with Excel. So I'm just going to open this right here. You can see it opens Microsoft Excel, and this is what this looks like in Excel. So we created a first row right here. Every single value is within a column, and we created our second row right here. And again, we have 4 columns, 4 columns. And I think this makes it a little bit easier to visualize what is going on right here. So what we're doing right here. We're just creating rows, and every single comma separates a column. Now we can also read those files within Python. So let me show you. We use with open, we define the file name, test.csv. We're going to read this time, and of course, as always, as f. Now we need to create a reader object. So previously to write, we created a writer object, and now we want to have a reader, so csv.reader, and we pass our f right here. And now we can iterate over this reader, so we can say for, and we will get 1 row for every single iteration. So for row in reader. For now, let's just print row. And you can see we're getting this row right here. That includes Max, Jenny, Adam, and NPC. Then we have an empty row. And then we have Susan, Peter, Wolf, and Adam. And now we could also, within those lists, iterate over the individual values. So we're first iterating over the rows, and now we can also, within this for loop, iterate over the columns. So we have a for loop inside of a for loop. So for column in row print column. And you can see we're getting all of the individual values. So how does this work? We are first iterating over the first row. So during the first iteration, we hold this row that includes all of those values. So we have all of those values inside of a list. Now, for this row, we again iterate over every single element inside of this list. And for the first iteration, this inner loop will hold max. We're going to print max. We then go to the beginning. Second iteration, this column holds Jenny. We print Jenny. Third iteration, this inner loop holds Adam. We print Adam. And the last iteration, inner loop holds NPC and prints NPC. Once this inner loop cannot find another element anymore, we break out of this loop and we go back to the outer for loop. The outer for loop now includes the second row and will therefore hold another list that includes all of those values, so Susan, Peter, Wolf, and Adam, and go on to the inner loop. For the inner loop, we again have now Susan for the first value, because that's the first element in the new list. We'll print Susan, go back to element 2, Peter, 3, Wolf, and the last one, Adam. It will break out of the loop, go back to this loop. We do not have another row, so we'll also break out of the outer loop, and we go on. And of course, since we do not have any code afterwards, the program is essentially done. So that is how a for loop inside of a for loop works. And of course, you could also have a for loop inside of a for loop inside of a for loop. So you can stack as many for loops as you like, but of course this also gets a little bit confusing. But this is how you read and write JSON data and CSV data. Let's understand classes and objects in Python. A class defines a blueprint, and an object is an instant from that blueprint. If you think about humans, for example, you could say that all humans belong to the class human. So a human is essentially a blueprint. And the blueprint for a human could define that humans should have legs, eyes, a brain, and so on. But not every human is the exact same. So you could say that every single human is an object, so an instance from the blueprint. We might have the human with the name Jonas, we might have the human with the name Mary, and so on. And let me show you how this works in Python. So let's create a class, human for example, like so, followed by a colon. And now we could, for example, for every single human, create a method. So let's define that one right here. Def greet, for example. So every single human can greet. We need to pass self right here, but you do not yet need to understand what self means. And now I'm just going to print hello, for example, like so. So now we have this greet method right here. And now we've created this class human that creates a blueprint. And now let's create an instance. Let's create the human Jonas, for example. And he's going to be equal to human, like so. So this is how you construct a human. And now to access the method of this human, we can use the dot notation. So Jonas, the object name, dot, followed by the method we want to call. In our case, we want to call the greet method. And let me execute or run this code. And you can see we're getting hello in the console. Now I could also have a second human. Let's say I have the human Mary. And Mary is also equal to a human. So we construct a second human. And now we can also use Mary.greet because of course Mary can greet as well. And we're getting hello twice. So we're getting hello for Jonas and hello for Mary. So a class creates a blueprint for an object, and an object is then an instance from that blueprint. And you should usually only define this class once, but you can create as many objects as you like from that single blueprint. So one class and multiple objects. Let's now understand the Dunder Init method. Last time we created a class, but all of the objects were pretty much the same. And of course this is not really realistic. So let's now create a new class. And let's say that this class is for heroes, for example. So now we want to create a couple of objects of type hero. But now every single hero has a different power level, a different name, a different age, and so on. So all of those things are different. And in order to attribute this difference when constructing the object, so the instance from this class, we use a constructor. So this constructor will be called whenever we create a new instance, so a new object from this class. You can define the constructor by using def, so we're just creating a method right here. And that method always has the name Dunder init, like so. And right here, within the brackets, we have to use self. So what is self? Self always refers to the object that has been created by using this constructor. And you will understand this in a second. But next to the self parameter, we can also define other parameters. So we could, for example, use the parameter name and the parameter power level, for example, like so. And now we could say that self.name is going to be equal to name, and self.power level is going to be equal to power level. And you'll understand this in a second. But for now, let me just create two heroes. So we create two heroes from this class blueprint. So the first hero is going to be Saitama, and he's going to be equal to heroes. And actually this class should have the name hero, so that was my bad. So Saitama is going to be equal to hero. And for the name, let's of course define Saitama. And for the power level, let's say it's 1 million, for example. Doesn't really matter. And now let's create a second hero. So for example, the hero Goku, he's going to be equal to a hero. And the name, of course, is Goku. And for the power level, let's use 10,000, like so. And now, if I'm going to print Saitama.name, I'm going to get Saitama, and I can also print Goku.name, and now I get the name Saitama and Goku. And I can of course also print the power level right here for both of those instances, and we get the power levels. So let me explain to you how all of this works. When creating a new object, so this object that will store within the variable, we call the constructor like this. And this right here just says construct an object from this blueprint, and use the constructor that we defined right here to construct this new object. So we call this constructor, and self now refers to the object that will get constructed by using this constructor. So for Saitama, we're calling the constructor. Self now for Saitama points to Saitama, so just to the object that has been created by using the constructor. So for Saitama, self points to Saitama. For Goku, self points to Goku. And of course, for every single object, there exists a new self. So you can have self 1,000 or 1,000,000 times if you have thousands or millions of objects. And self always, for every single object, points to the object that has been constructed by using the constructor. And now we use this constructor, and we pass those parameters right here. So Saitama is the argument that we pass or store within this parameter. And power level of 1 million, or whatever this is, will be stored within this parameter right here. And now we say self.name, and self.name refers to the variable name of this object Saitama later on, in this case, and to the variable name of Goku in this case. To this variable of the object, we pass the value that we pass as an argument right here. So we take this argument, get it into this parameter, and say assign this parameter to the variable of this object. And this here, just to make it clear, can be anything. So this could also be A, B, C, and whatever, so it doesn't matter. And now we can also say that self.name is going to be equal to ABC, and power level is going to be equal to QSA. So the object variable name will still be name, but the parameter, so the placeholder, is now ABC, as you can see. So this argument now has the parameter name ABC and QSA, but the object variable name is still going to be name, because we just use this parameter to pass the actual value to the object's variables name and power level. So if I'm now going to execute this, this will still work the exact same. And now this is pretty useful, because now we can also create class methods right here. So we can, for example, say def greet, and right here again we have to use self. So self points to the object that has been created by using this constructor. And now let me for now just print self.name, for example. And now if I'm going to call the greet method for Saitama, let me show you. So Saitama.greet, we will print Saitama. So you can see we're getting Saitama, because self for the object Saitama points to Saitama, and self.name points to the variable name of the object Saitama, which of course is Saitama. And now we could, for example, use this to print something like f, so an f string, self.name is greeting you. And now we can use Saitama.greet, but we could also use Goku.greet afterwards. And now we will get Saitama is greeting you, Goku is greeting you. And you can see we now have different functionality for every single object. So we could now, for example, also create def attack. So we could create an attack function, self once again, and we could print f self dot name attacks you with a power level of self dot power level, for example. And now let's also call Saitama dot attack, for example, and Goku dot attack. And we're getting Saitama attacks you with a power level of 1 million, Goku attacks you with a power level of 10,000. To summarize all of this, you just call the constructor whenever you construct a new object from this class blueprint. And then you can initialize those values by passing parameters within the brackets. And most of the times, as previously done, use the exact same name for the parameter as for the class variable. But that's nothing you have to do. That's just a convention a lot of programmers do. So this would be following the convention essentially. And that's all you need to know about init in Python. Let's understand the difference between instance variables and class variables. So an instance variable belongs to a specific object, whereas a class variable belongs to the entire class. So all objects share the class variable. Let's now, for example, create the class enemy. And now let's again start by creating the constructor, because that's the first thing you should always do. So def dunder init. And for an enemy, we could, for example, say that we want to get HP, and that's actually enough. So self.hp is going to be equal to HP. So this right here is an instance variable, because every single instance, when creating an enemy, will have a different value for HP. So we could, for example, now create a new enemy. So we could have enemy 1. He is going to be equal to enemy. So we are going to construct a new enemy by using the class constructor. And for the HP, we'll pass 100 right here. We can now have a second enemy though. We'll construct that second enemy once again by using the constructor. And that one is going to have 50 HP. So I see an instance variable is different for every single instance of this class. So for the first enemy, HP is 100, and for the second one, it's 50. So it's obviously different for every single enemy. Now I could also create a class variable though, and you'll add a class variable right here. So directly within the class. You do not pass it within the constructor. And that could be a species, for example. So all enemies might have the species enemy, because they're all probably our enemies. And now I do not have to define the species right here within the constructor. But if I'm, for example, going to print enemy1 dot species, I probably get enemy. And if I'm going to print enemy2 dot species, I probably also get enemy, because of course all enemies share the species enemy. So this right here is a class variable that will be shared along all of the objects, and this one will be different for every single object. And that's all you need to know about instance and class variables in Python. Let's now understand instance methods, class methods, and static methods. So let's start by creating a new class, human, for example. So class human, colon. We've previously seen how to create a class variable. So let's create a new class variable of population count, for example. So population count is going to be equal to 0. Now I'll also create the constructor, so def dunder init self. And for every single human, let's, for example, create a name and an age. And let's say self.name is going to be equal to name, and self.age is going to be equal to age. But now every time we call the constructor, so every time we create a new human, we should probably increment the population count, right? Because we're getting a new member for our population. And we can do so by calling the class name, because this is a class variable. So this class variable belongs to the entire class. So I'm going to call the class, so human dot population count, like so. And I'm going to increment that one by 1. So every time we call the constructor, we'll increment human.population count by 1. Let's start by creating an instance method. And this instance method works on an object and can access instance variables. So it can access those variables. And we've already seen instance methods. An example would be def greet. And by using self right here, we can access all of the instance variables. So name, age, and so on. And we could, for example, just print f hello self.name. So we're just greeting ourselves. But I mean, why not? Now let's create a human, for example. So let's create human 1. He's going to have a name, for example, of Jonas and an age of 25. Let's create a second human, and he's going to have a name of Gabak and an age of 28. And now if we are going to call human1.greet, we're getting hello Jonas, and for human2.greet, we're going to get hello Gabak. So as you can see, by using an instant method, we can access all of the instance variables right here, and we can do stuff like this. Now within an instance method, it's not really possible to access the population count right here, for example, so a class variable. In order to do something like that, we should use a class method. So a class method works on the class and can access class variables. How can we create a class variable? Let me show you. We can again define a function, and that one could have the name getPopulationCount, for example, like so. And right here we are not going to use self, but we're going to use CLS. And if we want to use a class method, we also have to declare it right here. So we should use Init, and right now we should say class method. So we have to define this, or we have to mark this as a class method. And now I could, for example, print cls.populationCount. So by using CLS, I can access all of the class variables right here. And now I could, for example, just print cls.populationCount. And now I can access this class method by using the class name, so human in our case, dot, followed by getPopulationCount. So by this class method right here. Let's run this. And you can see we're getting 2, because at the moment we have 2 humans. Let me now just create 2 more humans. So I'm going to copy those lines right here. And this one will be human 3 and this will be human 4. Actually, names don't really matter in this case. Let me just show you that we now get 4. So this class variable now keeps track of the population count, and we can output that one by using a class method. So by using a class method, you have access to class variables. And now there also exists a static method. And that one is an independent utility method that can't really access anything. So why would you even want to use that one? Let me show you an example. Imagine we wanted to verify the age, for example, of a person. We can do so by saying def is adult, for example, and that method should just accept an age and should output whether the person is older than 18 or not. And if we want to use a static method, we have to declare it right here as a static method, like so. And now we can use an if condition, for example. So we can say if age is greater or equal to 18, then we want to print you are an adult. And now we can just use the static class method on the class. So again, human dot, and now we can use isAdult right here, and we have to pass an argument right here, and in our case the age. So let's use 21, for example. I'm going to print this, and we're getting you are an adult. We can also pass 17, and now we're not getting anything. But we could of course fix that, so we could also say else print you are a little kid. Let me execute this, and we're getting you are a little kid. So you can use a static method if you just want to create an independent utility method. So something like checking age, for example. But most of the times you'll especially use instance methods and class methods. Let's understand encapsulation and naming conventions. In order to understand that, let's again create a class, and that class could have the name person again. We again create our Dunder Init constructor, like so, and let's also define a name for the person. So self.name is going to be equal to name. But now let's imagine that we only want to use self.name to greet the user. So def greet, for example, and let's print hello self self.name, and of course we need to use an f string, so f right here. And now let me create an object, so an instance of the class person. Human1 is going to be equal to person, name is going to be Jonas. Now I call human1.greet, and I'm going to run this. And you can see we're getting hello Jonas. And now encapsulation means that we want to hide internal details of a class. So the name right here is an internal detail. And no one actually really needs to access self.name. For example, we only want to give the user access to this greet method. So we only need this greet method to greet the user. But we do not need this name anywhere else. And we also do not want users to access this variable anywhere else. But at the moment, we could actually just say human1.name, and we could print this out right here. So let me copy this, print human1.name, and now we would get human1.name. But to now actually say that this here should only be used internally and should never be accessed from outside, we have a naming convention, and that is an underscore. So a leading underscore means internal use only. And that one looks like this. So self._name is equal to the value that we pass as parameter right here. So now I could still use human1.greet, for example, and right here I can just access self._name, and this should work. Let me show you. And actually this needs to be human1, and we're getting hello Jonas, so this still works the exact same, but now I marked this as private. So this here is marked as internal use only. The only problem is, to be fair, you can still access it theoretically. So print human1._name, for example. And you can see we're getting Jonas. You can see we're getting this warning from the code editor, so access to a protected member _name of class. But that's actually all we're really getting. So we're not getting an error, and theoretically this is possible. But I wanted to show this to you because a lot of developers use this underscore to mark something as private. So to summarize, encapsulation means you want to hide all of the unnecessary internal details from outside. So things like names should not be accessed from outside. And to mark them, you just have the naming convention of using a leading underscore. And that's all you need to know about naming conventions and encapsulation in Python. Let's now understand getters and setters in Python. And in order to do so, let's again create a new class, and that one could be the class human once again. Again, we are going to def our init constructor, and we're also going to add a name once again right here. And now we are again going to say self._name is going to be equal to name right here. And this here again is marked as private, so we should not touch this from outside. But maybe we want to get access to the value from outside, or maybe we want to set the value from outside. And under those circumstances, you can use getters and setters. So the user should not directly access this property right here. But if we want to give the user the possibility to access this property, for example, we want to offer a getter and a setter. So a getter just returns the value when an attribute is accessed, and a setter obviously sets the value. To define a getter, we first mark a getter by using @property, like so. Now we use def followed by the name, so the property name. And that is going to be name. Right here we can now use self, and we just have to return self._name, because that is the property name. And now to access a getter from outside, we first need an object, so human1 is going to be equal to human, and the name is going to be Jonas, and we can now access this getter right here by using the object name, so human1 dot, followed by the getter name. So the getter name is name. So human1.name, and this will return the name. But let me also print this out right here. So we're getting Jonas in the console. So getter will get us the name if we are calling the getter. And you can just call the getter by using the object name, followed by a dot, followed by the getter name. And now you can also define a setter. And you define a setter by using followed by the property name, so name dot setter, like so. So this right here defines that we want to create a setter right now. Again, we say def name. Again, we're getting self. And we also have to pass a value right here when calling the setter. And now we can, for example, just say self._name is going to be equal to the value that we pass to the setter when calling it. To now access the setter, I again have to call the object, so human1, followed by the setter name. The setter name is name, so human1.name. And now we can just set the value by using or by assigning it by using an equal sign. So the new name could be Lisa, for example. So by doing so, we're accessing the setter and setting the name. And you can see now in the console, we're getting Lisa because we've previously set the name to Lisa. So what is even the point of the setter? Of course, like this, it doesn't make too much sense. But now we could also verify the value, for example, or we could check whether the input the user enters is correct. So we could, for example, do if value. So if a value exists and the value is not empty, only then we're going to set self.name to value. So now this here still works. But if I'm going to do this right here, so if I'm going to pass an empty string, then we're still having Jonas because this setter will not set the value if the value is empty. And now we could also add a warning for the user. So if value exists, then we can just return right here, because then of course the value was valid. But if no value exists, then we're going to get to this part and we can just print you are an idiot, like so. Let me print this, and we can see we're getting you are an idiot, because of course the name is not valid. If I'll add Josie once again though, then we get Josie right here. So let's also create another setter so you really understand how this works, and probably also another getter. So let's add the age variable. Let's say self._age is going to be equal to age. We're going to add a getter and a setter for age. So add property to add a getter, def age, self, and we're just going to return self._age, like so. Now let's also add the setter, and the setter is a little more complicated but also pretty easy. We just use add age.setter. We define an age, we have self, and we have to pass a value. And right here we could check if value is greater than 0, because of course an age that is less than 0 doesn't really make sense, and probably greater or equal to 0. And if that is the case, then we can say self._age is going to be equal to value. We're going to return, and otherwise we're just going to print what are you doing, bro? And now let's also try to access the age getter. So let's create a new human. So human is going to be equal to human Jonas 24. And now let me just access the getter and the setter. So print human.age. And let's test this. We're getting 24. And human.age is equal to, let's try -2. So this shouldn't work. What are you doing, bro? And let's use 4, and we're getting 4 in the console. So now this works. So this is how you use getters and setters in Python. Let's understand inheritance in Python. Inheritance means that a class can reuse and extend behavior from another class. So let me show you. Imagine we're having the class human, for example. And let's start by using the constructor, so def dunder init. And every human has a name and an age, for example. So self._name is going to be equal to name. Self._age is going to be equal to age. And now let's imagine that every single human can talk, for example. So let's use def talk, like so. And let's just return an f string that says self.name or _name is talking to you. And now of course I could create an instance of this class human. So I could create the human1, which is going to be equal to human, and for the name we could initialize that instance with the name Jonas and the age of 28. But now imagine we wanted to create a class hero. So we want to be able to create heroes. But actually a hero is also a human. So a hero will also have a name, he will have an age, and he will also be able to talk. So just implementing the exact same code over and over again would be kinda repetitive. And we can fix this by using inheritance. Let me show you. We are first going to create a class hero, and now we need opening and closing brackets And the class hero should inherit from the class human. So we just defined human right here. And the rest stays pretty much the exact same. And for now, let me just pass. Now I also want to create a hero. So I'm going to create a hero. And let's actually just say hero and human. So hero is going to be equal to hero. And the name is going to be equal to Saitama. And the age is going to be 25. So as you can see, even though we did not use the constructor right here for our class hero, since we are inheriting from human, we are automatically calling the human constructor for the class hero as well, and therefore initializing our hero, who is also a human, with the values Saitama and age 25. And now our human is going to be able to talk like so, and our hero is also going to be able to talk. Now we also need to print this because we're just returning it within the method. So print hero.talk. And you can see we're getting Jonas is talking to you and Saitama is talking to you. So when using inheritance, the class who inherits from the other class basically has access to all of the attributes and methods the class it inherits from defines. And this class is what you call the child, and this is what you call the parent, because the child inherits from the parent. In our case, the hero inherits from the human. And if you think about it logically, it also makes sense, because of course a hero is also a human, but a human is not necessarily a hero. So parent, child. But now, of course, there also exist different kinds of heroes. So we could have a hero who is a mage, we could have a hero who is a warrior, and so on. So let's also create a class mage, for example. And that class mage is a certain type of hero. So mage could inherit from hero, for example. And I'm also just going to pass right here. And I'll also create a mage who's going to be of type mage. And she's going to have the name Blizzard, for example, and age is 22. And now I'm also going to print mage.talk. Let's print this. And we're getting Blizzard is talking to you. So now our mage is inheriting from the class hero, and our hero is inheriting from the class human. So in the end, both mage and hero are inheriting from the class human. So hero is a direct child of human, and mage is a direct child of hero, but hero again also inherits from human. Now for the hero class, we could also define other methods. So maybe a hero can talk, but maybe a hero can also attack. So def attack. And now let's just return right here f, so an f string, self dot underline name is attacking, like so. And now let me also call or print hero dot attack. And you can see Saitama is attacking as well right now. And let me also delete this, because we do not need this anymore, like so. And now I can also print mage.attack. And this works as well. So Blizzard is attacking, Saitama is attacking. If I would now print human.attack though, that will not work, because of course our human is not inheriting from our hero. So again, our human is not a hero. Our hero is a human though. So it only works this way around. Only the class who inherits from the parent class will have access to all of the methods and properties of the parent class. But now imagine a mage has a slightly different attack than a hero. So a mage should probably also be able to attack, but we want to have a slightly different version. And under those circumstances, we can use method overriding. You override the method by just using the same signature. So def attack self. So this is the signature. And now we can, for example, return under those circumstances again an f string self dot underline name is shooting a fireball at you. And now I'm going to run the code. So we have our hero who is attacking, and we have our mage who is attacking. And we're getting Saitama is attacking, and Blizzard is shooting a fireball at you. And this here is method overriding. So you just use the same signature, and you can define a different behavior within the method body. Now, of course, we could also have a class variable, species, for example. So species is going to be equal to human. And now let me just print human.species, like so. And let me run the code. And you can see we're getting human. But now I can also override the species within our hero. So this here could be a species being equal to hero. So let me now also print hero.species. And now we would get the species hero. So I'm overriding the property, the class variable to be precise, within our hero. And now I can of course also override that class variable within our mage. So species is equal to mage. And I'm actually just going to print mage.species as well. And you can see this works. Let me also show you how this works when we use a population count. So let's use population count being equal to 0. Let me also say that human.population count, every time we create a new human, I want to increase our population count by 1, for example. So human.population count plus equals 1. And now let me also create a method to get the population count. So def get population count, like so. This is going to be a class method because we're accessing a class variable. So I also need to get CLS right here. And I'm just going to print CLS.population count. And now let me, for example, use human.get population count. And let me execute that as well. And you can see we have 3. So every single instance, human, hero, and mage count as a human. Because of course all of them are humans because they inherit from the human class. So inheritance just means I'm basically a human. I'm just going to extend that a little bit. So I may be a human, but I'm, for example, specialized in something. And another example would be an animal. So you have all kinds of animals, and all kinds of animals are similar in certain aspects. So all of them are an animal, for example. All of them might have a brain. So I can create a general blueprint for all animals, and then you can attribute the differences between the individual animals by using inheritance. So by creating a subclass, for example, a subclass dog, a subclass cat, and so on, that inherits the general behavior of an animal, but extends this behavior by adding things that might be typical for that kind of animal, for example. So I hope you get the idea. So to sum up, inheritance just means that a class can reuse and extend behavior from another class. Let's now take a look at super. And I also want to show you another example of inheritance. Imagine we're having the class animal right here. And let's also start by creating the constructor, so def dunder init. And every single animal will have a name and an age, for example. So self.underline_name is going to be equal to name, and self.underline_age is going to be equal to age. Now every single animal should be able to move, so def move, like so. And right here, let's for example now just print an f string that says self.underline_name is moving, for example. And now let's also create another class that inherits from animal. So class line, for example, inherits from the class animal. And now for a line, we maybe also want to add a byte force. So we also want to create a new constructor for our line. So def dunder init. And now for our line, we of course also need to define a name, an age, but we also want to use a byte force. But our parent constructor, so the animal constructor, also expects to get a name and an age. So we somehow now need to call the animal constructor within our line constructor. And we should first pass our name and age to the parent constructor, so to the animal constructor, before initializing the byte force. We can do so by using super. So super calls methods from the parent class inside a child class. So I can use super right here, dot dunder init. And as you can see, the code editor already shows us that we're calling the animal constructor, and we need to pass name and age to the animal constructor, so to the parent constructor. Name is going to be the name that we'll pass as a parameter to our line constructor later on, so name. And age is going to be the age that we'll pass to our line constructor later on. And now I can afterwards also initialize self.underline_byte force, for example, which is going to be equal to byte force. So let me now just create a new line and a new animal. So let's say animal is going to be equal to animal, name is going to be whoop, and the age is going to be 4. Now I can also create a line afterwards. So let me create a line, and that one is going to be equal to a line. As the first one, we have to pass the name, so maybe Hamza. Second one is going to be the age, so maybe 11 years old, and the byte force is maybe 7000, like so. And now we have those two objects, so an animal instance that only needs 2 arguments and the line instance that has 3 arguments. But now a line can also move, and maybe a line should have a little more output than just this print statement. So let me create def move self, and you can see we're essentially overriding this method right now. But now we can also, by using super, call a method from the parent, for example. So we could use super right here, brackets, dot, and now we could, for example, call the move method right here. And if I'm now going to call line dot move, for example, you can see we're just getting Hamza is moving because our line has the name Hamza and he's moving. But now I could also add something else. So I could also print he is super fast. And now I'm getting Hamza is moving, he's super fast. If I'm now going to call the animal.move method though, let me show you, animal.move, we're only getting whoop is moving, and we're not getting he's super fast. So we're just calling the parent move method, so the animal move method, by using super.move, and afterwards we also added this print statement for the line. So by using super, we're able to extend the behavior of the parent class, and you especially oftentimes use it to call the parent constructor, and then add a couple more properties for the child. Let's also create a cat, so you'll see that once again. So class cat inherits from animal, like so. Def dunder init self. A class will also have a name parameter, an age, and maybe a jump height. So now again we have to call the parent constructor by using super.init, like so. We pass a name, an age, and that should be it. And self._jump underline height is going to be equal to our jump height. And now I can also extend the move method for the cat. So let's say def move, and we're going to call super.move. So we'll also call the parent move method right here. And now we can also say print, but she is jumping from time to time with a jump height of self. Let's actually turn this to an F string. So self._jump height, like so. And now let me also create a new cat. So cat is going to be equal to cat name is Peter, age is 4, and for the jump height, let's actually use 200. And now I'm going to call cat.move as well. And now you will see, for the normal animal, we just get whoop is moving. For the line, we get Hamza is moving, he's super fast. And for the cat, we'll get Peter is moving, but she's jumping from time to time with a jump height of 200. So to summarize, by using super, you can call methods from the parent class inside the child class. And those methods can be the init method or just normal methods. So that is up to you. Let's take a look at polymorphism. The word comes from the Greek words poly and morph. And poly means many, and morph, change or form. So many forms. And let me show you what this means. So let's, for example, create a class, car. We'll use a basic constructor, so def dunder init. And every single car should have a speed, for example. So speed. And we're going to say that self._speed is going to be equal to speed. And now every single car can drive. So def drive self. And we're just going to return an F string that says the car is driving at a speed of self._speed, kilometers per hour, like so. But now let's also create a sports car, for example. So class sports car inherits from car, and let's actually just override the drive method. So def drive self, and let's actually just return the car is super fast. And now I'm actually also going to create another class. So maybe I'm going to create a Bobby car that inherits from car. And I'm going to define the drive method that also has self. And I'm just going to return this car is barely driving. And now I create one car for every single class. So I create a normal car that is going to be equal to car. Speed is going to be 100. I create a sports car that is going to be equal to a sports car. Speed is going to be 400. And I create a Bobby car that is going to be equal to Bobby car, and speed is going to be 4. And now I'm going to call the drive method for every single car. So car.drive, sports car.drive, and Bobby car, so Bobby underline car.drive. And actually I need the equal sign right here, and now this works. So I'm going to execute this, and actually I need to print all of them. So print car.drive, print sports car.drive, and print Bobby car.drive. And now we're getting the car is driving at a speed of 100 kilometers per hour. The car is super fast, and this car is barely driving. And that is basically all that polymorphism is. So all of those ones are cars, but we're having many forms for the drive method. So we have this form of driving, we have this form of driving, and we also have this form of driving. So the form of driving is slightly different for every single car. So polymorphism, many forms. And actually, in my opinion, this is a super basic and intuitive concept, but a lot of programmers value this a lot. So I thought that it's important to at least mention it within this course, even though you'll probably do this by default and you do not really have to think about it too much. Let's understand duck typing in Python. Let's first of all, in order to understand that, create a class duck, and we'll define a class variable, wings. And a duck has 2 wings. Now we'll also define a method, so def speak, for example, and we're just going to print Kwarg, like so. But now let's also create a person. So class person, and let's actually say that this person also has wings, and the person has 2 wings as well. And now our person can speak as well, and we're just going to print Kwarg as well. And this right here is what you call duck typing. So an object is used based on what it can do, not what it is. So you basically say, if it looks like a duck and behaves like a duck, it is a duck. And of course, since our duck looks like a duck, behaves like a duck, it is a duck. But our person also looks like a duck, behaves like a duck, so in Python we also say it is a duck. And that's basically all that duck typing is. And it's also a concept that a lot of people speak about. It's, in my opinion, not that important, because I personally think that this here doesn't really make too much sense. If you have a duck, why wouldn't you just name it duck? But since you might hear about it, I thought I might just introduce it to you very quick. Let's understand Dunder methods in Python. Dunder methods are methods Python calls automatically. And important ones are Dunder Init, Dunder String, Dunder Eq, and Dunder Length. So let me show you. Let's create the class hero, for example. And the first Dunder method that you already know is Dunder Init. And we've previously used it a lot already. So def Dunder Init self. And now for a hero, we can, for example, pass a name. And we could say self.name or self._name is going to be equal to name. Now let's create a new hero. So hero is going to be equal to hero. And for the name, let's pass Goku. And now this Dunder method, so the Dunder Init method, will be called by Python automatically every time we create a new object. So we just define the Dunder method right here, but we never have to explicitly call it. In fact, we are calling it by using this syntax right here. Let's now also try to print our hero. So print hero. Let's run this. And you can see we're just getting main hero object at 0x000 whatever. So this here is just the memory address. And this right here is also a Dunder method that is being called. In fact, it is the Dunder string method. And the default behavior of Dunder string is that Python will just output the memory location of this object. So this location right here. But now we can override that behavior by using def dunder string, for example, self. And now we could, for example, return an f string that says this is the hero self dot underline name. And now let me print the hero once again. And you can see now we're getting this is the hero Goku. So when printing an object, Python will automatically call the dunder string method for you and execute whatever we have defined right here. If you do not define this one right here, Python will of course automatically call the built-in dunder string method for you. Similar, when calling the constructor without defining the dunder init method, Python will also automatically call dunder init for you, but without parameters. The next one would be equal. So let me create a second hero. Let's say this here is Goku, and our second hero is going to be Saitama. And we create a hero that has the name Saitama. And now we're going to print whether Goku is going to be equal to Saitama. Let's print this. And we're getting false, because of course Goku is not equal to Saitama. We can now override the behavior by using dunder equal. So dunder eq. So def dunder eq right here. And you can see we're getting self and we're getting other. And now we can, for example, return if self, so self dot underline name is equal to other dot underline name, for example. And now let me just call this again. And we're getting still false because the names are obviously different. But if now Saitama would also have the name Goku, and we run this again, you can see we're getting true in the console. So by overriding the dunder equal method, you can define custom behavior when comparing two objects. Let's now also understand the len method right here. And actually let me just try to print the len of Goku, for example. I'm going to execute this, and you can see we're getting a type error. Object of type hero has no len. So the dunder len method is actually not implemented by default. So if you want to access len, then you have to create it, but Python will recognize it once you define it. So def dunder len of self. And let's now, for example, create a second parameter, maybe power underscore level, and self dot underline power level is going to be equal to power level. And now within the dunder len method, we could, for example, return an f string. And I want to show you that this here does not work. But let's try it. So let's return an f string that says the power level is self dot underline power level, like so. Let me also remove Saitama right here, and let's just print the len of Goku. And actually we need to pass a power level, so maybe 100. Let's execute this. And you can see string object cannot be interpreted as an integer. So when using len, you always have to return an integer, so a number. So if we want to return something, we should just return self.powerLevel. Let's also remove that one, and let's execute this. And you can see we're just getting 100 in the console. And I'm going to be honest, I never really used the len method, but maybe under some circumstances you want to use it. So to summarize, a dunder method is just a method that Python calls automatically when you do a certain thing, like checking for equality, creating a new object, trying to print out the object, and so on. And the most important ones are init, string, equality. And probably you want to use len from time to time. Let's understand Dataclass in Python. And Dataclass automatically generates common methods like dunder init, dunder equal, and so on. So let me show you. Let's create a new class, food for example. And now we want to mark this class as a data class. In order to do so, we first have to say from data classes import data class, like so. And now we can mark our class food as a data class by using data class, like so. So now this here is a data class. And now, as already mentioned, the data class will automatically generate common methods like dunder init. So defining object properties for a data class is super easy. Maybe a certain food has a certain amount of calories, so I can define calories like so, and say that this here is of type int, for example. We might also have a food name, so name, that one could be of type string. Maybe we also have protein of type float, fat of type float, and carbohydrates of type float. And now we could also add is healthy, so is the food healthy, and we can say that this here is type bool. So it's either healthy or it's unhealthy. And now let's create a food. So let's, for example, try to create a banana. So banana is equal to food. And you can see, even though we did not define a constructor, it already shows you that we have to pass a name of type string, calories of type int, and so on. So it automatically created the constructor for us. And now the name is banana, calories, probably 100, protein, probably 1.0, fat, probably 5.0, carbohydrates, 30.0, and it's actually kind of healthy. So true, like so. And now let me create another food. So maybe chocolate equals food, chocolate, calories 250, protein 6.0. I don't even know the numbers, to be honest. Fat probably 15.5 or 4, and carbohydrates 27.7, and it's probably not that healthy, so false. And now let me also print banana equal chocolate, for example. I'm going to print it, and you can see we're getting false in the console. So those ones do not seem to be the exact same. Let me maybe check if they are the same, if they have the same name. So is it now the same? And you can see we're still getting false. Now let me just copy the entire object, and let's say this is banana 1. Is banana 1 equal to banana? We are getting true. So you can see if the values are the same, those two objects are going to be the same. So this is the built-in equal function defined by a data class. So to sum up, you can use a data class to just write a little less code because it automatically generates common methods like dunder init, dunder equal, and so on. And that's all you need to know about data classes in Python. Pip is Python's package manager. It lets you install, update, and remove external libraries that come with Python. Instead of writing everything yourself, you install ready-made tools with one command. Think of pip like an app store for Python code. You search for a package, install it, and then import it in your program. That's it. Pip's only job is to manage libraries so you can focus on writing code. Let's understand pip and packages in Python. To install packages, you first want to open a new terminal right here, and this will open a terminal within your project. So for me, it's the folder Python project, because my entire project is currently within this folder. To install a package, you usually use pip. You usually install pip together with the Python installation. To check whether you have pip, you can use pip --version. And if you have it, you should see the version number right here. So for me, it's 23.2.1. Now to install a package, we can use pip install followed by the package name. In our case, let's test the package numpy. And that one is a package that you use pretty often for machine learning. You can see it now started to download the package, so the numpy package, and this will take a short while. And once done, you get successfully installed numpy 2.4.1. So numpy now has been installed, and from that point on, we can use numpy within our project. So let's import numpy. We can also use an alias for numpy that is a little bit shorter, for example, and oftentimes you see np. So import numpy as np. And now we could create a variable x, for example, and imagine we want to store a list inside of this variable. So equal np dot array. So by np, we're accessing the package, and we're accessing the dot array method of that package. And now that one expects a list. So maybe the list 1, 2, 3, and 4, like so. And now if we wanted to get the doubles, we could do doubles being equal to x times 2. And now I can just print the doubles. And you can see we're getting 2, 4, 6, and 8. So the doubles of those values. If you remember, previously, we had to use something like this. So 1, 2, 3, and 4. And to now get the doubles, so list doubles being equal, we would have to do something like this. So num times 2 for num in y. And now I could also print the list doubles and we would get the exact same result. But numpy makes this a little bit shorter, for example. And this here is a super simple example, but numpy is really powerful. I just want to show you that some other users wrote packages, and now you can also use the functionality from those packages by just installing them within your project and accessing the methods. So you do not always have to do the work someone else already did for you. And this is super good because a big community in Python creates a lot of useful packages. and you can start building on top of it instead of having to do the exact same stuff. Now let's also take a look at all of the packages that we've installed at the moment. So let me open the terminal, and right here let's enter pip list, which will return a list of all of the packages that you have installed. And you can see here is a list of all of the packages. So those ones are a couple of predefined packages. So we have pip, idna, colorama, requests, and so on. And right here you also see NumPy. So at the moment we have NumPy version 2.4.1. If someone creates a package and makes it available for other developers, you can usually also find it on PyPy. So I can just enter PyPy right here, go to this page, PyPy, and right here you will find pretty much all of the packages. So we could, for example, also find NumPy right here, and it will give you the NumPy library right here. And on the page you can of course find the official website, documentation, source code, and so on. So if you need any information about the package, you can usually find it right here. You could also search for another package, so pandas for example. And this is also a pretty important package for data science and artificial intelligence. So you could also click on it and you would find information about pandas. You also have the installation command right here. And if you need a little more, you can just read the documentation again. So if you need any information about a package, just go to PyPy and search for the package. And of course, you can also find new packages right here. So let's go back to our code editor. And now imagine you have this list right here of dependencies, so of packages that you've installed. But now maybe another developer wants to use your project, for example, but of course without the dependencies the project might not work. And he might also actually need the exact same versions, because probably NumPy version 1 has different commands than 2, and 2 has probably slightly different commands than 2.4. So it might make sense to somewhere store all of the packages that you've installed within this project together with their version number, so another developer can take a look at that file, install the exact same packages, and then use the code that you've already written. And you can do so by using pip freeze followed by this sign right here. And now you can define a file name in which you want to store all of the requirements. And usually the name is requirements.txt, so in a text file. I'm going to press enter, and this will create a requirements.txt file, as you can see. And you see here we have all of my dependencies. So this project depends on Certify, 2025, 11, 12, charset normalizer, and so on. So this here is always the package name, 2 equal signs, and then you have the version number. So we need the exact same version number to make this project work. Or at least we should have the exact same version number to make this project work. And now I can also uninstall something. So I could, for example, use pip uninstall numpy, for example. This will uninstall numpy from my project. I'm going to proceed. So yes. And we successfully uninstalled numpy 2.4.1. So I now want to use numpy, for example. So let me delete all of this and let me just print the doubles like so. And I'm going to run this. You can see that we're getting an error. Import numpy as MP, module not found error. But now, since we have this requirements.txt that stores all of the versions that this project depends on, we can simply reinstall all of the versions. So we can create or open a new terminal. And now to install all of the requirements from this file, we can use pip install -r followed by the file name. In our case, requirements.txt. We're going to wait for this to run. This will install the collected packages. As you can see, it's numpy for us. And now successfully installed numpy 2.4.1. So I see it installed exactly this numpy version. Let me run the code. And you can see this here starts to work again. So as you can see, by using a requirements.txt or an external file to be precise, the name could be anything, you make your code reproducible. So other developers could use your project and get the exact same results. And that is really important, as you can imagine, if you work as a team. And that's all you need to know about pip and packages in Python. A virtual environment is like a container for one Python project. Each project gets its own Python version and its own libraries. One project can use Python 3.7, for example, and NumPy version 1. Another one could use Python 3.10 and NumPy version 2. They don't affect each other and can't break each other. Without virtual environments, all projects share one global Python install. Virtual environments keep projects isolated, predictable, and safe. So let me now show you how to create a virtual environment. Let's start by opening the terminal In Windows, it's CMD. So you just type CMD into the search bar and open the command prompt. Now I usually go to my desktop, but feel free to go anywhere. So CD for change directory. And let's go from my user account to my desktop, like so. So now we're on our desktop. And actually I will create a new folder for all of my environments. Environments, like so. Let me go into that folder so I see what is going on. And let me also change directory into environments, like so. So now within the terminal, I'm within this folder right here. And now I can create a new environment by using Python -m venv for virtual environment, followed by the environment name, env. This could be anything technically though. So this could also be this. This is just going to be the name of your environment. And I'm going to use env because that is pretty common. But feel free to use anything. And you can see this installs this folder or creates this folder, which is going to be our first environment. Now we've created this environment. If we go into that folder right now, it will look similar to this. If you're on macOS or Linux, you might have a bin folder instead of the scripts folder. And that folder is important. So on macOS, on Linux, bin, and on Windows, scripts. So let's go into the scripts folder. And to activate an environment, we now have to call this file, so activate. And we can do so by just typing in, let's go into env / scripts on Windows, bin on macOS and Linux, / and let's call the activate file, like so. Let's press enter. And now you can see we are inside of our environment. So now the environment is activated. And now we can install packages right here, for example. So pip install numpy, for example. Let me press enter, and this will now start to install numpy within this virtual environment and successfully installed numpy. So if I'm now going to go into this env folder, into lib for libraries, side packages, you can see that I have numpy in here. In order to deactivate the environment, we can just type deactivate right here. And you can see we left our env, so our environment. We can now create a second environment by saying again python .m venv env2, for example. Let me create that one. And let's go to our environments folder, and we now created env2, so the second folder. And now we have the second environment right here. Let's go in there, go to lib, side packages, and you can see numpy is not in right here. So this here is a completely different environment with its own packages and of course also its own Python version, if we wanted to do so. And now I can of course also activate the second environment by again saying env2 / scripts / activate. Like so. This activated our second environment. And now I could of course also install something in here. So pip install pandas, for example. And this will again take a little bit. And in a couple of seconds, within our lib folder, we will also have pandas within our side packages, as you can see. But since pandas depends on numpy, we also installed numpy right here. So you see pandas has a lot of dependencies, so we installed all of the dependencies that pandas depends on, and we installed pandas. But now we can also store all of the dependencies within a requirements.txt file that we can later on use inside of another environment to get the exact same packages. So let me do so by using pip freeze requirements.txt. Let me press enter, and this will now create the requirements.txt file. So now let's go back to our environments, and right here we have the requirements file. We have the requirements file right here because we executed this command within this folder, so within our environments folder. And you can see within this file, I now have all of the dependencies, so numpy, pandas, pytc, 6, tcdata, and so on. And now I could just create another environment. So let me first deactivate that one. So deactivate. I'm going to create a new one by saying python .m venv env3, for example. So we created that environment as well. And now let me activate that environment. So env3 / scripts / activate. This activated our third environment. And now I can install all of the requirements from the other environment by using python -m pip install -r requirements.txt. Let me execute this. And this will now install all of the dependencies that we saved within our requirements.txt file. The installation has been successful, so let's go into env3. let's go to lib, side packages, and you can see we have the exact same side packages right here. So by using this requirements.txt, you can share your requirements, so the exact packages and versions that you're using for your project, with other developers, for example. And that is really, really useful. And by creating different environments, you can also create different projects where you have the proper dependencies for every single use case and every single project. And that is all you need to know about virtual environments inside of Python. Whenever you use a website like Facebook, a program like Photoshop, or basically any modern app, requests are always involved. But why? Think about Facebook. You open your browser and type a URL into the search bar. That action alone is already a request. You're sending a request to a server that basically says, give me this website. The server receives your request and responds. Either it sends back an error and says, sorry, you can't access this, or something went wrong, or it responds successfully and sends you the website data. Now imagine you are on Facebook and click on one of your friend's user profiles. At that moment, you're sending another request to the server. This request says something like, hey, give me the data for this user, please. Again, the server receives the request and decides what to do. Either it responds with an error, or it sends back the requested data so it can be displayed on your screen. When working with requests like this, you'll often hear the term API. An API is exactly that, a clearly defined access point on a server. It provides a URL where you are allowed to send requests. The API receives your requests and responds with either an error or with data. There are different types of requests, called HTTP methods, and each of them has a clear purpose. A GET request is used to get data. For example, when you click on the profile of your best friend Mary, your app sends a GET request to retrieve Mary's user data so it can be shown on the page. A POST request is used to send new data to the server. For example, when you create a new account or post a comment, your app sends a POST request that contains this new data. A PUT or patch request is used to update existing data. For example, when Mary changes her profile picture or updates her bio, the app sends an update request to modify data that already exists on the server. A delete request is used to remove data. For example, when you delete a post or remove a comment, a delete request is sent to the server. After every request, the server sends back a response that includes a status code. Status codes tell you what happened. The most important ones to remember are 200, so everything worked fine. 400, the request was wrong. 401, you are not authenticated. 403, you are not allowed to access this. 404, the requested data does not exist. 500, something went wrong on the server. So in short, your app sends a request to an API, the server processes it, and the server responds with the status code and, if successful, some data. That's the core idea of how websites and APIs work. Let's understand how to use APIs in Python and how to work with requests. In order to use requests, so in order to get data from an API, for example, we first have to install the requests package. So let's open a terminal. Within the terminal and within our folder, let's type pip install requests, so the requests package. Installation will take a short time, and once done, we can use it by importing requests like so. So the requests package. Now let's first of all define a URL. So where exactly do we find the data that we want to fetch? And in our case, I thought that it might be kind of cool to use the Pokey API. So let's click on Pokey API. And as you can see, by entering https:/pokeyapis.co/API-v2 Pokemon/ditto, we are getting all of the information about this Pokemon. And of course, you could also enter another Pokemon. I'm not really sure about all of the names, so I'm not going to do this, but you get the idea. You can just call this URL, and if you enter this URL, you will get all of this information right here. So things like name, abilities, cries, and so on. Don't even know what all of this is. And you can of course also just use this URL, so you could copy this one, paste it within your browser, and this is essentially already an API call, because you can see we are now getting all of the information as a result. So we're getting a reply with all of the information about this Pokemon. So abilities, ability name, and so on. And of course we can call this API via internet, the way we did right here, but we can also use Python to call this API. So let's do that. Let's first of all define a URL. So let's send a URL to this endpoint right here. Now to get the results, we say that we want to store them within a response object, and this is going to be equal to requests.get, and we want to do a get request to our URL, so to this point. Let me for now just print our response so I see what is going on. And you can see we're just getting this response and we're getting 200. 200 means everything went all right, so it's okay. We can also get the status code by using .status code, and this would just be 200 for OK. And we can also get the JSON data or extract the JSON data by using .json. And you can see we're having all of this stuff. So now we could of course also store that within a data object. So data is equal to response.json, like so. And now we could of course also just print data like so. And let me remove this. And this should give us the exact same result. And now you can see we're getting this dictionary right here. And now I can access all of the properties by using bracket notation. So I could access abilities, for example. Let me run this. And you can see we're getting this array right now that includes ability and so on. So let's take a look at the documentation. And you can see we could, for example, access species, and species includes name and URL. So let's, for example, access species because that is a little bit easier. Now we're getting another dictionary within this dictionary that includes name and URL. So let's now, for example, access species of name. So species of name. Let me run this. And we should now, of course, get ditto. So this here seems to work. And this is how you use the request library to fetch data from an API, for example. Let's now understand time and date in Python. In order to work with dates and times in Python, we should first import datetime and time delta. So from datetime, like so, import date, time, and time delta, like so. And now we can get the current moment, for example, by saying datetime.now, so calling the now method. And we can of course store this within a variable now. So now is equal to datetime.now. Let me print now. And you can see we're getting the current date. So 20/26/01/14 and the current time. Now I can also create a variable for the future, for example. So future is going to be equal to now plus, and you use time delta to create a difference. So to create a certain span. So time delta of days being equal to 1, for example. So this creates a span of 1 day. So this value, so future, the variable future, will store the current time plus 1 day. Let me execute this and also print future. And as you can see, now we're getting 20/26/01/15. So this is actually 1 day in the future. Let me show you by also printing now. So you can see we're getting 20/26/01/14 and 20/26/01/15 at the exact same time. You can now also format a date by calling the string format time function right here. And right here you can see you can format the time by always using %m for the month, %day for the day, %y for the year, %h for hours, %m for minutes, and %s for seconds. So that is just the syntax. And now you can of course combine all of those values as you like. So I could, for example, say I want to have %d for day, dot %m for month, dot %y for year. And let me just print this. And you can see we're getting 14/01/2026. Of course, I could also add the time. So let me say %h for hours, colon, %m for minutes, colon, %s for seconds. Let me execute this once again. And you can see we're getting 13/47/20. So we formatted our date and our time. And of course, you could also do something like this. That's of course up to you. And now the formatting would just be a little bit different. And you could also say today is, comma, let me print this. And we're getting today is 14/01/2026, 13/47/56. And that is all you need to know about datetime and time delta in Python.